Hello. Hey, everybody. Let's see some more good GMs in the room. This is going to be fun. Does everyone want to tell me where you guys are from? Just drop it in the chat. Let me know where you're from. And let me know if you can hear me okay. We got some music going on to just get it warmed up because I know it's first thing in the morning in New York, in the US. GM indeed. Where's everybody from? From Poland. Chris, you're from Poland. Awesome. What time is it there? Probably middle of the morning, right? Hey, Patrick's in the house. Atlanta, nice one, Alex. Yeah, Argentina, I like it. More people from the Southern Hemisphere like me. I'm from Australia and Melbourne, so very Southern Hemisphere. Christopher, NYC, very cool. Good morning. Hey. All right, we'll give this another few seconds and then we get started because we've got so much fun stuff to cover here today, guys. So much fun stuff. Midwest, nice. A lovely day. That's right, Chris. You betcha. Netherlands, welcome. Australia, Kelly's from Australia. Welcome, mate. I'm from Melbourne. All right, let's get started. Let me know, guys, if you can see the slides, right? You can see the screen any minute now. There you go. You can see the slides, all right? Let me know if you have. Yeah, that's right, Chris. Great way to get warmed up. You know, something about the music and the grooves, just get the energy up, right? Because that's what we need. That's what we need. We're going to do some serious coding now. All right, guys, welcome to the 2022 Chainlink Hackathon. We are so excited that you guys could join us. It's been a fantastic couple of weeks. It's been really, really fun to watch everyone learn a bunch of new things, get involved in a whole bunch of coding. We've had some amazing colleagues of mine do some phenomenal workshops, all of which were live streamed and are available on YouTube. So if you missed any, go back and check them out. You're going to learn so much, like a ton of stuff on this, okay? But let's get cracking because we've got quite a lot to cover today. And what are we going to do today? Well, I'm glad you asked. So we are going to build a DAO. Totes wow, right? So that's what we're going to do. We're going to build a DAO. We're going to break what a DAO up is in. We're going to break up what a DAO is. Do a deep dive in that shortly. I'll give you all the ideas around it. And we'll go through the DAO governance life cycle, right? What that means is there are steps to actually doing governance on chain. So we're going to build an on-chain DAO, completely on-chain. There's another type of DAO, which is sort of hybrid or off-chain, but we'll get into that in a moment. So that's what we're going to do today. We're going to build a DAO and run through a bunch of steps in governance, all right? But first, let me tell you a little bit about myself. My name is Zubin Pratap. I'm a developer advocate at Chainlink, freshly minted into Chainlink. Before that, I was a software engineer at Google. And before that, I was 15 years a corporate lawyer. Now, that's why I'm so passionately interested in DAOs, okay? When I started my legal career way back in 2003, the world was very different. Very, very, very different, right? The idea of a corporation is different. The ideas of how you organize and coordinate human activity was also extremely, extremely different. And so I came to realize that things are changing. Like in 2003, the future looked totally different from what it is now. The future is no longer what it used to be, which is why I am personally so excited about DAOs, right? So who is this for? Well, today we're going to do a live code along session, right? So we're going to be doing some coding. Actually, we're going to be doing a ton of coding, right? And so it's kind of useful if you do know how to code. But if you don't know how to code, at least stick around for the first presentation that I'm going to run through the key concepts of what an on-chain DAO is, how it differs from an off-chain DAO, what governance life cycles look like, the key ideas and components. And the benefit for you, if you're not a coder, for sticking around, at least for that, is that you build really solid mental models, right? So that means you can have intelligent, analytical conversations with people. You can present your point of view from a point of knowing, okay? And I've broken it down into really simple steps for you guys. So definitely stick around. There's also going to be a feedback form. In fact, what I'm going to do is I'm going to get you the feedback form link right now, and I'm going to post it in the chat, okay? I'm going to post it for you guys later as well. And definitely take a look at that anytime during the presentation, during the live code along, and definitely at the end, I'll show you the link again. You know, give us your feedback. We want to get better. We want to help you guys get involved in the community and get better. Okay, so that's really, really number one. Now, for those of you who are coders, we're going to get some massive coding hacking action going. All right, so we'll be using tools like TypeScript, Solidity for the blockchain development stuff. Obviously, all of this is based on the Ethereum chains. We're going to be using the hard hat development environment, and we're going to be using the awesome tools given to people by OpenZeppelin, right? A library of smart contracts that make development and governance a lot easier, make development of tokens a lot easier. So some great stuff there. Now, just some very quick housekeeping, because there's quite a bit of stuff that we're going to have to cover. And so what we're going to do is I develop on a Mac environment. I'm sure some of you may be on Windows environments. If you are in a Windows environment, please get hold of the Windows subsystem for Linux. I'm going to put that in the link. There you go. Sorry, I'm going to put the link there in the chat, right? Please get a hold of the Windows subsystem for Linux. Download it now, right now. All right, get it down so that by the time I finish the presentation and we start coding, you guys are ready. Now, in terms of the coding setup, I'll be using a VS Code editor, right? Please make sure you have Node.js on your system. Please make sure you have Yarn on your system, because we'll be using the Yarn package manager and the executor. And I've just talked about using the terminal and command line. Windows users, please get the WSL, the link's still on the screen. And then we're going to now install some developer dependencies because they take a little time to download. Let's get that out of the way. While that's downloading, we're going to get into all bits and pieces, the meat and bones of what DAOs are all about, okay? So I'm just going to quickly, I'm going to leave that thing on the screen there for you to install WSL, but I'm just going to quickly hop over to my coding environment. So I'm going to just, this is what we're going to do, okay? I'm just going to make a directory and see I'd already done something similar. So I'm just going to write over that and we're going to change into it. So for those of you who don't know, if you do an and $_ like that, you make a directory and you switch into it. There you go. I'm in the DAO demo directory, right? Now, in this directory, what we're going to do, I'm going to paste this for you in the chat. We are going to do this giant yarn command, okay? We're installing a bunch of packages, okay? So I'm just going to paste that in there. You can see there's hard hat, there's OpenZeppelin contracts, there's TypeScript, because we're going to be using TypeScript in this. There's TypeChain, TS Node, Ethers version 5, hard hat chai, Node, hard hat deploy, a whole bunch of things, okay? We're going to do a whole bunch of things. Let's just do that. Now, while that's running, yeah, while that's going, let's see what we can do. Let's see what we can do on the presentation, getting back to the presentation. Awesome. So let's talk about the basic concepts of what DAO is, right? So a DAO is a decentralized autonomous organization. That's DAO, right? Now, everybody has a good idea what decentralized means. Okay, something that's not centralized, it's sort of distributed across the community. Autonomous means a lot of the things are done automatically, right? The smart contracts, the code executes automatically when certain conditions are met. To me, the most interesting part is that it's a form of organization. That's the most interesting part. It's a way to organize and coordinate human effort, human activity in a way that's decentralized and autonomous. Super exciting stuff, just absolutely mind-blowing, unprecedented, the kind of stuff that makes history, you know what I mean? So the reason why DAOs are so rad, is because it's a new form of organization. It distributes the decision-making power. It shares ownerships among participants. So if all of us are participating in a DAO, if we're token holders, well, we kind of own we have a stake in the DAO, if you like, right? And so it distributes ownership amongst amongst the participants. It also automates the execution of decisions, right? And it cryptographically secures and makes the whole thing transparent, which is pretty awesome when you think about it, right? It's pretty radical. So let's get our fundamentals right. Now, this space is full of all kinds of terminology. Not all of it is helpful, right? So what is a smart contract? Let's forget about the word smart contract for a moment, right? It's actually basically a computer program that's stored on the Ethereum blockchain. That's it. That's the idea. That's the mental model you need to have. When someone says smart contract, you hear application or software code on the blockchain. Okay, that's the easiest way to break it down for starters. Of course, it's a bit more than that. But for now, when someone says smart contract, you hear computer program running on the blockchain, stored on the blockchain. Okay, and it's a fundamental building block to all Ethereum applications. That's all it is. It's code on the blockchain, stored on it, executed on the blockchain. The reason why they're very cool, and I'm going to run through this because we've got so much to do, is they have 5 major benefits, right? Security, guaranteed execution because it's all on the blockchain and nobody can control it and turn it off. Transparency because you can verify and check everything on block explorers and things like that. Trust minimization because you can rely on the code, which is usually open source, and you can examine it and you can decompile it and all that, check what's going on. So it's, you don't have to trust that, hey, Zubin's saying what, Zubin's doing what he said it's going to do. The code will take care of that. And efficiency, because you can coordinate activities in this decentralized, trust minimized, transparent, cryptographically secure way. Lots of stuff in there. So lots of terminology. Like I said, don't freak out if you're new to this. Don't worry. It takes a bit of getting used to. Okay. Now, a DAO needs governance, right? This is the automated bit. So governance basically means decision-making, deciding what gets done, what doesn't get done, and coordinating the activity in a way that's, fair and representative of everyone's interests. So there are 2 main types of governance, guys. One is on-chain, which is the kind we're going to do today. The TLDR for on-chain governance is that, please close the chat pop-up. Yep, I've closed it. Cool. And let me get rid of my face as well. There you go. Much better, right? Okay. So on-chain governance is where all the voting, the decision-making, the transactions get directly done on the blockchain. Okay. So if you're voting for something, the vote gets stored on the blockchain. The transaction gets executed on the blockchain. That's on-chain. Off-chain or hybrid is where you use non-blockchain applications like IPFS or Snapshot, right, to collect all the voting data, which are cryptographically signed transactions, but they're not actually stored on the blockchain. They're just stored somewhere else for the moment. And then a single transaction is sent onto the blockchain, ideally through something like, like an Oracle, like a Chainlink node that basically sends the data onto the blockchain. And then that single transaction is stored on the blockchain, which is the outcome of all the voting that was collected and aggregated off-chain. But there are advantages and disadvantages to this, right? So on-chain governance is the classical gold standard of governance, right? It has more mature tooling. There are applications and stuff that make it easier to do. But as we know, gas is expensive on the Ethereum network, right? And so doing it all that way can actually be so expensive for some people that if it's going to cost me $100 to exercise my vote as a token holder, I may not do it. So that's not great. On the other hand, off-chain governance there's more immature tooling. It requires a lot more work. So, people like you can build Chainlink nodes or integrations with Snapshot and other stuff to make off-chain governance come onto the chain easier via Chainlink nodes. That'll be an awesome integration if someone wants to build that. That's the kind of tooling we need. But the big advantage is you don't pay for the gas of voting. You just do the vote, you send the transaction to an off-chain database or Snapshot or tool like that. And then a single transaction is signed and sent onto the blockchain representing the actual outcome, right? So those are the key advantages and disadvantages. Now, let's talk about the DAO we're going to build, right? What are we going to build? So we're going to have 4 Solidity smart contracts, okay? 4 pieces to the DAO that we're going to build. The first is a governance token, which gives us the right to vote. The second is the governor contract, which is sort of the administration piece, right? This is the one that has all the logic around when do you vote, how do you propose a proposal, how do you execute a proposal, and so on and so forth. Then we have a time lock. Now, a time lock is basically, think of it as a way to pause the execution of a winning proposal. So if a proposal is successful, it gets votes in its favor, it's the winning proposal. You pause the execution for a period of time so that the people who are unhappy with it can leave. They're not dragged along into this outcome that they didn't actually want, right? So that's a little queuing mechanism. We call that the time lock. We have another contract for that. And then we finally have the target contract. In our case, we're just going to call the target contract box, okay? Basically, a target contract is the thing that gets governed. Okay, it's the thing that the voting proposal affects. It changes the state of the target contract. So that's going to be our box contract. And so we'll get into all that in the code in a moment. Now, before we do that, there are three important time-related concepts that we're going to see in the code. But I need you to understand that now. And if you have any questions, ask me right away, because these concepts could get confused when you're coding, right? There's a lot of cognitive overload. So I want to make sure you understand these concepts. The first is voting delay. This is the time interval between when a proposal is submitted and the voting power is fixed based on how the voting power is distributed across token holders, okay? And this time interval is measured in blocks. It's not like human time in seconds and minutes. It's measured in blocks, the number of blocks added on to the Ethereum network. Yep. So this is basically there to make sure that users can unstake their tokens or delegate their votes and stuff like that before a snapshot of the voting power is taken. So this is the voting delay. The proposal is proposed, and before voting starts, there's a voting delay. Then the voting delay is over, but the voting period starts. This is the window of time in which you get to exercise your votes, right? This is the, if you're having an elections in a country, this is that week in which you go to the polls, okay? That's the voting period. Minimum delay is quite different. This is the period of pausing in the time lock. Remember how we talked about in the time lock, we queue the proposal and we make it pause for a little while? That period for which it's pausing is the minimum delay, okay? So those are the three main time concepts you need to know. Now, how are we going to do this? We're going to write those 4 contracts, right? Then we're going to write a bunch of deploy scripts. And then we're going to write some of the interaction scripts. So there's a lot to do. I'm going to move reasonably quickly. And then we are going to nail this baby, okay? We're going to get this. So if you want to refer to stuff as we go along, you can take a look at this repo. I'm going to post it here in the chat links. Yep. There you go. So this is a fairly stripped down version. This is exactly what we're going to be writing today. This is the same code there. So if you're falling behind, by all means, go to this link and take a look at it and make sure that you grab stuff off there if you want. But I'll code along as we go, and let me know in the comments how we do. Moses, I'd love to show my hand. I'm glad someone likes my hand movements, man. Like, not a lot of people like it, but it's just the way I talk. And yeah, I'm glad you're okay with the energy. But I'm going to keep my head out of this because it's not the most attractive thing. Plus, we've got to start with the code, right? So is the link broken? Let me check that. Hang on. Shouldn't be. Ah, interesting. Okay, let me see what's going on there. It could have also been, yeah, that's why I had marked it as private. That's why it's not visible. Thank you for letting me know. Sorry about that. All right, I'm going to do a hard refresh and see how we go. So if you do Command-Shift-R or hard refresh, it should show up now. Yeah, thank you. Shalman, I think, OX Shalman, is that how I pronounce your name? It should be okay. Yeah, cool. Are we done? Are we done? Can you guys get it? Let me know. Can you guys see it? Awesome, Rutger. Thank you for letting me know. Thank you. Cool. So are you guys ready to rock and code? Shall we? Let's do this. Okay. Let me make sure. Can you guys see my little terminal thing here? And I'm going to take away the GitHub repo in a moment. You guys can see my okay, excellent, beautiful. Excellent. So I'm just going to minimize that, and let me know if it's not big enough. Okay, I've nicely zoomed in, so it's massive for me. But let's just get started. So we've already added a bunch of the yarn dependencies. We saw that. Now what we got to do is we got to initialize this as a hard hat repo, right? So hard hat is this incredible tooling that we're going to use. I'm sure you've seen a lot of hopefully you've seen some of the coding workshops that Patrick and others have done on how to use hard hat. Awesome tool. So we're going to use it. Pretty straightforward. All we got to do here is we've got to type in hard hat. That's pretty much it, okay? And then what we do is we want to choose the option that goes the number 4 option there, right above create an empty hard hat config JS, okay? Because we'll manually do that. So we do that and we're done. So if we look at what we've got in there, we've got our node modules, hard hat config package.json. Great. Now let's fire up our VS Code. For me, I just do code dot and it sets it up, but there is some config required for that. And let's see, there we go. You can see that now. I'm just going to swap the windows around so that I know what's going on. Cool. Okay. Now, guys, I have way zoomed this in. So I need you to tell me if you can read my package.json all right. Can you read that okay? It's clear enough? Just give me a thumbs up or something. Okay. I'm going to assume you can. Yeah, okay. So it looks all right. Okay, cool. So, excuse me. I'm going to keep having some tea because I've got a bit of a sore throat. It must have been all that singing of a lovely day. First thing we're going to do, let's get right into it because we have 4 smart contracts to build. Let's create a new folder, call it contracts. Okay. In that folder, we're going to create a new file. Let's start with our box.solve file. Remember, box is the target, right? It's the one that we govern. Our voting decisions are going to change the state of box, right? So let's start with that. Cool. Right. And so we do the usual, if I do SPDX, there you go, SPDX-license identifier. By the way, if you guys haven't already done this, you may want to check out this Solidity extension. It's pretty useful. I'm just going to put it in the comments for a moment, and you guys can, it's a VS Code extension. So some of the stuff that you'll see happening on my screen is because I have that, but otherwise you can just type in what I'm typing in and you'll get the same results, okay? So this box is going to be something, the box contract is going to be ownable, which means it's going to be owned by some other contract. Actually, it's going to be owned by the contract. We'll get into that in a moment. Sorry, it's going to be owned by the Timelock contract. We'll get into that in a moment. But basically what that means is that we're going to give one of the governance smart contract, the Timelock controller, we're going to give that one rights to control our box contract because that's how we make sure governance is automated, okay? You're getting an error with hard hat. Are you? Let me see that. That's probably because, see, have you installed 9.3? 2.9.3. And so you've probably got a version of Node that's incompatible. You may need to change a Node. If you're using 18.10, I don't know what that is, but let me see what version of Node I'm running, right? Yeah, I'm running 16.4.2, and that's okay. Yeah, LTE, I was thinking maybe the LTE one is what you've got, Freddie. You may need to use a different version of Node. Yeah, CK is right. That's what you got to do. All right. Cool. Coding, all the dependency stuff, right? So much fun. It's not fun when that happens. All right. So the first thing we're going to do is we're going to import from OpenZeppelin. We're going to import from the contracts folder something. It's an access control contract, right? So we're going to import that. Now, if you guys want to see where that is, here, I'm going to show you. If you go to OpenZeppelin, let me actually just go here. I'm going to put this link there, right? This is OpenZeppelin's public repo. So we can see that we're installing something from contract access ownable, right? And of course, Solidity will cry and complain and moan about it if I don't actually, of course, something like that would happen. It's because it's contracts. There you go. Right. And so you can actually take a look at it. If you go to contracts, and I'll do this quickly now so that you guys have a sense of how to move around the OpenZeppelin repo, and then you can do it for, when you're following along or later on when you want to understand what's going on. So this is the ownable contract that we're going to inherit from, okay? So we're going to say contract box is ownable. That's inheritance and Solidity, right? And then we're going to do a bunch of things. Now, the most important thing that we got to do is remember this is the contract that's going to store the value that we're going to change through governance, okay? So we're going to give it that value. So we're going to say uint 256 private. Let's make that a private. So this is a state variable that lives on the blockchain, right? In this contract, call it value. Okay. And then we're going to create an event for when we do change this. When we vote on it and we change the value, we want an event emitted anyway. So we're going to call that the value change event. That's going to be uint 256. We get the new value in the event that's emitted. Emitted. Then the most important function is the one that gets called in governance eventually. We're going to call it store. We're going to store a uint 256, which is the new value. So this is really going to be what governance is all about in our example here, right? This is what we're going to do. We're going to call the store function. It's going to be a public function because we need to call it from outside. And we're going to say only owner. Now, only owner is something that lives in the box contract, okay? It's a modifier. Solidity is something called function modifiers, which basically has additional bits of logic before or after a piece of code runs. And so the only owner modifier, I'll show you in a moment, basically says that only the owner of the box contract can call the store function. And remember I said we're going to make the time lock controller the owner. We'll do that later. So we reassign the state value, the variable to the new value, and then we emit our event saying, hang on, the value's changed, good news, and the value is going to be this new value that we've got, okay? Now, for those of you who are following along, thank you, Leo. You are absolutely right. I keep doing that. I forgot pragma, solidity. That would have been fun because when I run compile, that would have shown up. So you're going to just run with variance of 0.8.0. Okay. Thanks, man. Appreciate it. Thanks, Leo. Cool. So where were we? So we're going to store something in the blockchain. Now, if you want to look at it in VS Code, if you want to look at what ownable is like, you can actually just on Mac do a command, and I think in Windows it's control, right? So on Mac you do a command, and you can click on that, and it'll open it up from your. You'll see it's from your node module. So if you've installed the dependency, you'll see the entire contract there. And this is pretty much the same thing that you see in this repo, right? So it says contract module, which provides a basic access control mechanism. That's what you see here in the GitHub repo. And hey, contract module provides a basic access control mechanism. So it's the same thing, right? So I often just look at it in my VS Code if I need to see what's happening. So going back to ownable, I can show you what the only owner thing is, right? So there's a modifier here called only owner, right? And it basically says it requires that the owner is the sender, is the caller of a given function. So whoever calls store has to be the owner. Otherwise, it'll error. Okay. The next thing we want to do, excuse me, is you want to wait to later on check that the what the value is, right? We want to be able to retrieve the value that we have in here. So this is going to be a public function. It's going to be view because we're reading the state, and it's going to return the uint 256 that is the value, and it's just going to return value. Okay. So that's our box contract. Now, before we actually compile it, because that's going to be the next thing, let me close that. Before we actually compile it, we need to open our hard hack config, right? And you'll see it says 7.3, but my box is at 8.0. So what I'm going to do is I'm going to just change this to 8.9 for now. I mean, really 8 point anything will work. There's also something else I want to do. I actually want to change this, right? Because we'll see that we're going to start getting an error. You can leave it as this, but I'm going to just add some optimization here. So this is what we're going to do. We're going to make we're going to give Solidity its own little object, and we're going to say version. We're going to do 0.8.9 and make sure it's inside Solidity. Then we're going to have a settings object, and we're going to have some optimizations around the compiler here. So optimizer, and then we can do enabled, whoops, adding a little offset for my keyboard. So enable true, and then runs, we can do 100 for this one, that's fine. Okay, so what's this? We're basically configuring our Solidity compiler. We're saying using the 8.9, and we're going to try and optimize it. So when we run our compile scripts, that should be okay. Now, let's just check using Hardhat whether there's any issue with this contract. And the way we do that is to make sure it compiles, right? So we do yarn hardhat compile. It's the moment of reckoning, guys. Woo! Compound. Okay, now I'm going to do something really annoying every time something works, because it doesn't happen that often in coding, not as often as we like. Every time something works, I'm going to go, okay? You're just going to have to deal with it, because this is how I celebrate. Cool. Let's close that out. All right, now that we've got Sol, box.sol cooking, what we want to do is we want to start with our next token. Sorry, with our governance token, so our next contract. So we've done box. Let's do the next one. This is governance token .sol. Okay. Now this token is the ERC20 token that anybody in the DAO community needs to hold in order to exercise votes. Okay. So this is what gives you the right to vote. And it's an ERC20 token. Now, an ERC20, for those of you who don't know, is an Ethereum standard, which basically defines the interface and the specifications for a fungible token or a standard token, right? A token that can be exchanged. So currency tokens, for example, are ERC20 tokens, which means they expose a standardized interface that we can then interact with. Okay, so it has a standard spec, and we need to follow that spec, right? So if you want to look at the ERC20 token, the way it's done from the way we're going to inherit it from Open Zeppelin's repo, right? So I'm going to post it up there in the chat, show it to you guys for a bit, and you can take a look at it there. But let's start. So we do SPDX license, and this time, Leo, you'll be very happy to know that I'm not going to forget about my pragma, right? Hopefully I'll learn this lesson at some point in time, forever and ever and ever, but there's a very good chance that you, my friend, are going to have to keep watching out and letting me know when I screwed up. All right. Now, what we want to do, like I said, is we want to import Open Zeppelin /contracts/token ERC20, which is the GitHub repo thing I sent you in a moment. But we're going to use something called extensions ERC20. That's it. ERC20 votes.sol. Okay. Now, ERC20 votes is a little bit different. It's basically off the family of the ERC20 category, right? But it has the votes. It's an votes extension. What that really means is it gives us the ability to snapshot the voting power at a certain time, at a certain block. Okay, so we'll talk a little bit more about that in a moment. But the benefit of that is when we're doing a voting delay, we can snapshot everyone's vote. So we don't have a situation where people are suddenly acquiring a whole lot of tokens to manipulate voting power and so on and so forth. So we just want to make sure that it's a voting compatible ERC20 token that we're issuing here, right? Now, let's start with declaring the contract. So we're going to call this the governance token, right? And it is going to extend ERC20 or inherit from ERC20 votes. And let's start with giving our token a maximum supply, right? This is the maximum number of tokens that can be there in circulation at any point in time, okay? We're going to call it max supply. I'm going to turn that down. And then, so I can't read your name, but someone's asking me why I'm not using the latest Sol and Solcy version. If you want, go ahead. I'm just doing it because I don't want things to break. I don't want things to break in the live coding environment. This is the Solcy version stuff that I've used and I built it in. I just want to make sure that you guys have the smoothest experience. We don't want to get trapped in things like compiler issues and stuff when we're live coding. Yeah. So the max supply is going to be 1 million of these tokens, but denominated to 18 decimals, right? So I'm going to post a number here, okay? And hopefully it's right, but even if it's not, we can just run with it. It doesn't matter too much, right? So what I'm going to do is I'm just going to back post this entire command here. There you go. Cool. So that's going to be the first one that we put up, right? So max supply is going to be basically 1 million tokens up to 18 decimal places. So that's going to be 24, to the power of 24, basically. Okay, so that's 1 million tokens to 18 decimal. All right, and then what we're going to do is we're going to call a constructor. And since we're inheriting from these two, what we're going to have to do here is we're going to have to actually instantiate the ERC20 oops, ERC20, and we're going to pass in two things. On governance token's name, we're going to give it the very imaginative name of governance token, because I spent hours coming up with that one. And then we're going to give it a symbol, which is also taking me a long time to come up. So I hope you guys like it, GT. Okay. And then we're going to do ERC20 permit. And this is going to take the governance token name again as its value. Okay. So this is ERC20 votes basically inherits from these two. And so when we extend and inherit from ERC20 votes, we need to pass it the information it needs to instantiate its superclasses, its parent classes, its base classes, whatever you want to call it. And so that's why we have all that here. Okay. Why is this complaining now? Oh, yeah, that's why. Okay. And there's only one thing we need to do when we create our governance token. We need to call mint. And mint is going to send whoever calls the constructor, whoever creates this governance token, it's going to send them 100% of the money. Now, this is obviously not how you do it in a real life DAO, but the reason we're doing it now is we are the ones who are going to be voting for the purposes of this live coding. So I'm just going to give myself all the tokens and vote. Okay. In real life, obviously, there'll be a whole community of people. Right. Now, semicolon, otherwise it'll complain. That little red line won't go away. There you go. Now it's gone away. So we basically have our governance token ready. It's inherited from ERC20 votes. If you want to take a look at what mint is, _mint is, you can just click on ERC20 votes. And then for those of you who are using a Mac, I'm not sure what it is actually in Windows, but in Mac, Command-Shift-O will open all the symbols in a file, right? So if I'm looking for _mint, the other thing you can do is just go Command-P and go @ right? Whatever opens your command palette and then do @ I just do Command-Shift-O and it gives me that. And then I just look for mint, right? And I can see mint is in ERC20 votes. There is a function. I click on it. Whoa, it took me there. So cool. I love it. And basically all mint does is it produces the token, allocates it to the right person, and then writes the checkpoint. Remember, this is what we needed. The checkpoint is a snapshot of voting power in a particular point of time. And so we wanted that checkpoint written, which is why we're using ERC20 votes. Okay, cool. So now that we have that, that we've talked about checkpoints, we've got the governance token done. Now what we need to do is because we're inheriting a bunch of functions, Solidity requires that we override a bunch of functions that we're inheriting from. Okay, so the functions below are overrides required by, I don't know if it's override at 2 hours or 1 hour. I don't know, we'll find out. Required by Solidity. Okay. Cool. And now I'm just gonna hide that. Okay. Now we're going to do a couple of functions. The first one we're going to do is we're going to do after token transfer. Okay, I'm going to give it a few arguments. Let's talk about what arguments we give it. Well, we give it an address that is a from, an address that is a to, because we're talking about token transferring. We talk about how many tokens get sent, and basically, what after token does is it updates a whole bunch of state variables in the ERC20 votes and ERC20 and stuff around what are the total supply. Now that we've minted some, what is the total supply? And it also updates a snapshot. Okay, now who's got how many votes and so on, right? So after a token transfers, there's a bunch of state changes that need to be made. So that's what that does. And this is going to be an internal function that's overriding ERC20 votes. And like all overrides, we need to call the base class. Right? And so we just do from, sorry, no, actually mint is, I think, to and from. Yep. Okay. And the semicolon. So used to JavaScript and other stuff where you don't need to worry about that so much. Why is this complaining? That's interesting. Oh, sorry, no, it's actually to an amount because we're minting. Yeah, that makes sense. Okay. Then we need to do a couple more. We need to do something called mint, which is kind of similar as well. We have a to, which is an address type. and we're going to say how much we're sending them. I'm standing up, so I'm a bit offset from my keyboard. Sorry about that. Typing typos. ERC20 volts. Same thing, really. And then this one as well is going to call super. Oh, sorry. This should be after token transfer. Yep, and this one should be. That's an interesting little bug that we almost had there. Two, and then the amount. And this one needs to have from as well. Sorry, just to recap, I was getting ahead of myself. I was thinking of Mint. So just to recap, after token transfer takes 3 arguments, from, to, and amount, and all get passed into the parent class. Okay, I incorrectly put only 2 and amount the first time around, so make sure you change after token transfer to send all 3 arguments into its parent, and make sure you're calling super after token transfer, and Mint's fine. Now we need to do burn. So Mint is basically producing tokens, adding them to the total, adding them from the total supply. You make them available in the real world. Okay. Burn is the opposite, where you take them out of circulation and you make sure that you reduce the amount that are in circulation, right? So that's what burning is. So when you burn, again, you need an address that from which is being burned, and you need to specify an amount. Again, this is also an internal override, ERC20 votes. And this one calls the parent class. Again, no prizes for guessing that we do this. Okay, so what do we have here? We basically have a bunch of overrides because we're inheriting from the parent class. We need to override that functionality, but we just call the superclass anywhere. And that's all we're doing here, right? So let's do a quick compile check. Darn, hard hat, compile, please work. I'm not seeing any red, so that's usually a good sign. No squigglies. Is it premature? Oh, yes, awesome. Matt, we use superdot because we're calling the parent class, right? So when in object-oriented program, when you call the parent class that you're inheriting from, you call that function, but you have to say super. Super refers to the super class, the parent class, the base class that is being extended from. You call that function in the parent class. So that's the format. Cool. Yeah, Moses and Alec and Rutger, all of you guys, thank you for celebrating with me. That's awesome. I thought I'm the only one blowing this thing, but you guys are clearly with me, which is awesome. All right, so we've got 2 of the smart contracts down, baby, down. Yeah, okay. Now, just got to keep moving. Can't celebrate too long. We've got to now produce the governor contract. This is the one that does a lot of the voting mechanics, right? So proposing and executing and all that. Now, because we're doing it all on chain, we need to make sure we sort of reference it. I call it just like the governance standard, okay? Because this is all on chain. This is going to be the canonical version of doing on chain governance. So first thing we do, we create a little in the contracts folder, create another folder, and we're going to call it governance_standard. You can really call it whatever you want, but I'm just calling out that this is pretty much like the gold standard of what on-chain governance is meant to be, okay? And in that, we're going to have a governor contract sol. Okay, now I'm going to put here for you, because what we're going to do is we're going to use OpenZeppelin's wizard, okay, which is very cool. Now, OpenZeppelin is, it used to be I think it still has an auditing wing, so it audits a lot of the smart contracts that it produces and makes them available for the community. So it's highly dependable and secure. So we tend to like to use OpenZeppelin's tools because it makes it that much more secure for us, okay? So I'm going to post a link here to the wizard, and I'm going to open it up for myself as well. All right. Okay, so that's the wizard that we need to try and open up. So let me open that up here. And the wizard will help us produce a fairly standard kind of secure governance contract with a bunch of the concepts that we're going to need. Okay, so you see this, it's given us a bunch of tabs on the top. We chose governor because that's the one we're going to do. That's the governor contract we're going to write, right? We're going to write let me close box and governance, and here close the hard hat config. We're choosing governor contract, right? That's the next one we're going to write. So we make sure we click on governor on top. We're going to call this governor contract, right? Oh, maybe we should call it governance contract. What do you guys think? Let me see. What should we call it? Excuse me. Gosh, I need my tea. Right. I think it's probably better that we do call it governor contract because I think it won't conflict with some of the other stuff we write later on. Okay, let's call it governor contract. Now, voting delay. Remember, we talked about those 3 time concepts in my little mini presentation at the start. So voting delay is the delay between when the proposal is produced or made, created, and when voting actually starts, okay? Measured in blocks. So we're going to leave that at 1 block. The next one is the voting period, the period of time in which voting is even possible, your election period, if you like, yeah? So that's the period when you can cast your vote. We're going to put it in 1 week, but here's the cool thing. You'll see that the wizard tool starts, actually, and let me put away that thing. There we go. The wizard tool actually puts in a bunch of the data for us in this governance setting call, right? So 45818 is actually the number of blocks that get mined in a week. So for example, if I change this to 1 day, you saw how it changed to 6545? Watch again if I change back to the week, 45818, right? So that's all that is. So 1 week in blocks is 45,800 blocks, right? Because 1 block takes 13.2 seconds approximately. Proposal threshold is how much voting power should a person have before they're allowed to vote. We're going to leave that at 0. Quorum is how much of the total voting base should participate for this vote to carry, right? So we're going to leave that at 4%. So we're going to leave the standards here. Decimals 18, that's fine. We're using ERC20 votes. Yes, we are. We want a time lock controller because we want this to go through a time lock period where even though the voting has come out successfully, you want to pause on the execution of the proposal so that unhappy people can get out. Yeah. So we have a time lock controller. Excuse me. Fine. So all that's fine. Now, strangely enough, copy to clipboard is not working for me, and I don't know if it's working for you, right? So I'm just going to do this. I'm just going to copy it, and I'd recommend that you guys just copy it as well. Copy that. Copy that. Roger that. Okay. And we paste it in there. Let me get rid of that sidebar there. Now, there are a couple of concepts that we need to go through here, right? You see it's inheriting a bunch of things. We'll go through that in a moment. We'll also see that it has all the functions we talked about around voting delay and voting period, the quorum, which is going to be 4%. Here's the main meat of it, right? This is the stuff that really is important because we're going to come back to this later on. It does the proposal, it does the execution, so it handles all the mechanics of pushing a proposal through the governance process, okay? Excuse me. Now, what's important here is let's add some, so you see this governance settings in the constructor, right? We're passing through a bunch of information here. What we want to do is, this is actually 1 block we know is the voting delay. Okay, we know 1 week is the voting period. So let's just annotate this in these comments. This is I think this was the proposal threshold, wasn't it? Yeah. So that's fine. We don't actually need to change that. We leave that as it is. And you see here, governor votes quorum fraction, right? We see that this one has 4, which you'll remember is the quorum percentage. So this 4 is a percentage, okay? So this is 4%. 4%. And this is the quorum percentage. Okay. Now, what we need to do here is, right now, these are hard-coded in, right? Why is this complaining? Is that it? Yeah. See, sometimes the 1 semicolon, sometimes it doesn't like the commas. Coding is so much fun. Okay, so the governance settings, we're passing these parameters really into it, right? Because that's how we're instantiating the parent. But we don't want them hard-coded in. So we want to try and make this configurable. We want to be able to add this stuff in dynamically, okay? So what we're going to do is we're going to change the constructor for our governor contract, right? So the main constructor line you see, it takes in these 2 parameters already. We're going to add 3 more. We're going to add in a uint, 256, going to be our voting delay. We're going to add in another uint 256, which is going to be our voting period. And add a third uint 256, which is going to be our quorum percentage. Okay, these are all the variables that we mess around with. And we seem to have lost a bracket at the end there. That help? I'm so zoomed in, I'm having to scroll in all over the place. So what have I done here? That's why. I did it outside the bracket. There we go. Cool. And my format is kicked in. So we've added these three in, which correspond to this, the voting period, and the quorum percentage. Okay. What we should also do is, because we're going to be using those variables later on, so we should just declare a constant file. Why don't we do that now? Let's do it in the project root. Right in the project root, right? I'm going to do new file, and I'm going to do hard hat helper config.ts. Okay. And here I'm going to say export const voting delay, and we're going to give it the same value that we know. And we got to update this file here in a moment as well. Okay, so voting delay, we're going to say it's going to be 1, and then let me just copy this for a moment. So voting delay is going to be equal to just one block. Okay. We're going to do export const voting period is equal to that number that we just copied, which is 1 week in blocks. Okay, and then we want to do the quorum percentage. So we do quorum percentage. That was just going to be 4, and that one's going to be 4%. We're not going to need this right now, okay? But we have that handy, so we can get to it later on. I just want to do it while we're here. But now that we've passed all these variables into a constructor back in the governor contract, we need to make sure that those variables are passed. So we get rid of the hard coding, and here we just do voting delay. Oh my gosh. Thing is not working today. Okay, that one doesn't change. And this goes to quorum percentage. Okay, so all the stuff that we're passing into a constructor gets passed into the parent classes when instantiating them. Excellent. Okay, now yet another compile check moment. Okay, so let's get those party homes ready. Let's clear this out. Do yarn hard hat file. Happen? What do you think? It's gonna happen? Is it gonna happen? Oh yeah. I hope this thing lasts the whole night. It'll be very sad if I lose it. Not for you guys, it'll be sad for me. I'm sure you guys will be absolutely relieved when that thing breaks. Anywho, that's awesome. So we've got 2 of the smart contracts done. Yeah. Now let's keep going because we've got so much to do. So much fun. Now, in the governance standard, we're going to create a time lock controller, right? Or we'll just call it the time lock .salt file. Okay. This is the one that's going to pause the execution at the end. Okay. So thank you, Radka. Still celebrating with me, I see. That's awesome. So the time lock controller is going to manage our queuing system. People have voted, the proposal is successful, but before we actually automatically execute it on the blockchain, before the proposal actually comes into effect, we want to pause things for a moment so that people who are grumpy about it can leave, right? So that's why we have this queuing mechanism, right? Now, it's not the same as the voting delay and the voting period. So it's not the same as these 2 things, okay? That's for when the voting starts. The voting delay, the time lock delay is really, the time lock delay, which is the minimum delay, is about how long we have to wait before the execution of the proposal happens after the voting period is over. Okay, so let's get into that. We do our usual CDX, we do our pragma. How's that, Leo? Still remembering? And we can we'll just use this one because this is what I've got going. And then we do contract Timelock. This is actually going to be a pretty simple one, I think. Okay, let's just start with that. And what we want to do is this one's going to inherit from Timelock controller, which is something that OpenZeppelin gives us a lot of the functionality because governance is now fairly well understood. Okay, if you want to look at the GitHub code for that's absolutely right, Rutger. It's funny. This is a very funny comment. So, full disclosure, I actually asked a few of my South African friends whether they did have a Vuvuzela. And then one of them was like, are you sure you want a Vuvuzela? Because that's going to be really nasty for people. So you're right. I'm glad I didn't do it. This party tutor thing is bad enough, I'm sure. All right, so this is the Timelock controller there on your screen from OpenZeppelin that we're going to inherit. Okay, so we're going to import that in first. Import OpenZeppelin contracts governance. Then we got time. Hang on, is it? So L is lowercase, Timelock controller, but C is uppercase. .sol. Okay, I'm just going to copy that because it's easier that way. So contract Timelock is Timelock controller. Now there are a few things that we need to do, right? Because let's take a look at Timelock controller and you'll see why. Basically what Timelock controller does is, apart from the queuing also, it sets up a whole bunch of access control, right? Basically rights for different addresses or different contracts to do different things, right? So it sets up all the roles, the admin role, the executor role, and the proposer role, okay? So the admin role is someone that administers all these contracts, okay? The proposers are all the addresses that can propose a governance proposal, okay? And the executors are all those that can actually execute that proposal. Once the time lock period is over, they hit execute, okay? So we got to set up some of these permissions. We don't do it right now, we do it later on in the script, but a lot of that stuff is done in Timelock controller. So, we'll see here in a moment. Let me just instantiate it so it stops complaining. And then you'll see here in a moment how Timelock controller has a whole bunch of stuff around the roles and the allotment of roles to different accounts. Okay, so let's start with doing the constructor, and what this one will take is, because Timelock controller, let's click on it and see what it says. Timelock controller takes minimum delay, proposers and executors. It's an address array and a uint 256. Okay, so that means that's pretty much what we need to pass into ours as well. Okay, so we do uint 256, give it a minimum delay, which we'll have to pass in later on when we actually instantiate and deploy these contracts. Then there is an array of addresses, which is, because if it's data type, it needs to go into memory storage. And then we do proposers. So this is the list of all people or all addresses that have the right to propose. And then we do an array of addresses again, which are the executors. These are the addresses that have the right to execute stuff. Okay, and now we need to make sure that we pass all the stuff on to the parent. So we do parent minimum delay, we do proposers, and we do executors. And I take away that comma there so it'll stop yelling at me. That's pretty much it, guys. That's pretty much all the Timelock controller does. Now, I promised that I was going to show you, I know I have it open, I'm going to show you here. I promised that I was going to show you the various roles. So you'll see all the roles here, right? You see that there's an admin role, there's a proposer role, there's an executor role, and all these are just constants that this OpenZeppelin contract declares, so that you can assign these constants to different addresses. And you can see that here, right? So even when we instantiate, when we create the Timelock controller, you'll see that it sets, the role admin. Well, the Timelock admin role goes to the Timelock admin role. The proposer role, goes to the Timelock admin role, and so on and so forth, right? So, oh, Leo, I'm so sorry. That's really annoying. I'm so sorry that you're far behind. Really, all we've done so far is well, it's not all we've done so far, it's quite a bit, but very quickly, just to recap so that you can see what's going on. We've done box and governance token. which you probably saw, and we've done governor contract, and we're doing Timelock right now. So if you can copy these in, from this, the repo that I sent out. And yeah, Alex is right. It'll be recorded. Yeah, so you can try and follow along, try and copy all that stuff from there as well. But let's keep going because we have a lot. Leo, I hope you catch up, but I hope you can pay attention and get a lot from this anyway. I'm sorry your laptop crashed, man. That sucks. That's rough. So you can see that what Timelock controller does is it sets a bunch of roles up. Okay, that's all it does when we instantiate it. So this is really important from an access control point of view, and really that's all we need to do for our Timelock governance contract at this point in time. Okay, so again, it's time to do a yarn hard hat compile and see if it works. My trusty tutor in my hand. Let's go. Come on. Let's go. Come on. Yes! Oh my God, it's starting to die, guys. All right. Excuse me. Okay. Let me hide that one now. So what have we got? We've got a bunch of contracts that we've done. We've in fact got all 4 of our contracts done. Okay, so we've got box and governance token, and we've got the governor contract with the Timelock. So our smart contract piece is done. Excellent. This is good. This is good. Next, though, we need to get into some fairly involved stuff, which is all the deployment scripts. Now, deployment is the process where our smart contracts here are compiled into bytecode and put onto the Ethereum blockchain. Okay, we're not going to be actually putting it onto a live net or even one of those test nets like Rinkeby or anything. We're not going to do that. We're going to use the hard hat blockchain, the deployment chains that come with hard hat. Okay, so that's what makes development super fast. Plus, we can do some really cool things, some sneaky things, which you'll see later on. Okay, so now we're going to go into a bunch of deployment scripts. We're going to have 5 scripts. We're going to deploy each of the contracts, right? So that's going to take 4 scripts. And then we're going to do one script that does all the setup and governance process around taking away permissions. Remember how Timelock controller had a bunch of roles and access control stuff? We're going to tweak all that to get it right so that it's truly automated, truly decentralized. The deployer, the person who deploys the contract, shouldn't have all this control, right? We take away all that control. We do all that later on. But there's a lot of coding to do here, and some of it is boilerplate. So let's get started. Now, the important thing is we're going to use the hard hat development blockchain, as I mentioned. So it's an in-process blockchain, which is a fancy way of saying it runs in the hard hat binary or the hard hat program that we have installed, that we downloaded using Yarn. That's going to run its own separate blockchain, and we can compile our contracts here and deploy it onto that local blockchain to make sure it's all working. Okay, but again, I want to make sure that you guys have this. It was there in the you remember that big slab of Yarn add packages I told you guys to add? This one was there, but in case you missed it, this is going to be super important for the next bit. So I'm just going to paste this into the chat. Make sure you do install these 3 packages. Okay. And let me pin that, and I'll answer Victor's question. So make sure you do that. So Victor, your question, let me actually answer your question. I'll put it up in a moment. So Victor, your question is, Open Zeppelin code is pretty extensive. Do you think it's necessary to understand all this to the root and get a job and work in the field? I don't know. I don't know if this is the appropriate place to answer that, to be honest. Obviously you can't know everything, but it depends on what you get tested on, right? But I think the root of your question here, Victor, is that you're concerned about how much there is. There is a lot. Don't be overwhelmed by it, okay? As long as you keep going every day. Most of us don't know everything. Anyone who's telling you they know everything about the space is probably don't know how much there is, or they're just lying, okay? So don't let that overwhelm you. Just follow what we're helping you do. Watch the other Chainlink stuff that we've got in this hackathon. You will learn so much from that, okay? And you'll start to see a pattern emerge. So you can 100% do this. Do not let your self-doubt kick in and get overwhelmed if that's what's going on. If I misunderstood your question, I apologize. Ask it again, and I'll try and do a better job answering it. Cool. So hopefully you guys have got this Yarn ad business, because we need to have these packages for the next. So there are 3 of them. You can see there's the, oh gosh, sorry. I'm going to put better spacing there because it's not going to work if you do it that way. There you go. That should. So Okay, so the chat doesn't spread, but you'll see it's yarn add, hard hat deploy, and then there's a new yarn add. Okay, so we're doing hard hat deploy, we're doing Nomic Labs hard hat ethers, and make sure you do the at the rate of. Let me put that in separately, in fact, because that is really important. Make sure that the second yarn hat hard hat, yarn add comment looks like this, because it's going to be important. What's happening here is you're mapping Nomic Labs' hard hat ethers to the hard hat deploy ethers package, and you're adding a second package at the end called ethers. Okay, this at the rate of is really important because it sets up a mapping. Okay, so once you've installed that, we're going to be able to use this package, this one here called hard hat deploy. Okay, hard hat deploy is a really cool package. It makes writing scripts much easier, and it makes it easier to just do a yarn hard hat deploy, and it deploys a whole bunch of your scripts. Okay, so we're going to start now. Let me close this stuff out. We're going to start here in the root, start in the root of the project, and then create a new folder, and we're going to call it script. Okay, so excuse me. I beg your pardon. Actually, we don't call this one script. We call this one the deploy folder because we're still doing the deployment scripts. So we call it the deploy folder. And in this one, we're going to do 0, 1, because this way it executes in a certain order. Deploy governance token. And we need to do it in this order. Okay, so make sure you get the file names right. Deploy governance token. Now, for this one, you're going to see a certain basic skeletal structure in all the scripts, in all the deploy scripts we do. Okay, so it's going to look more or less like this. We end up declaring some asynchronous function. In this one, we're going to call it deploy governance token, which is going to be a type deploy function, and we'll import these types in a moment. It's an asynchronous function. It gets passed in the hard hat runtime environment, which is also a TypeScript type that we can import in a moment. And this will do a bunch of things. Let's just go console log. Wow. Okay. If it works, we should see that. And then we want to make sure that we do an export default deploy governance token here. Now we have a bunch of complaints here because this function is referring to a bunch of types that we don't have. So we import hard hat runtime environment from hard hat types. That is actually correct. We also do the deploy function, and this needs to come from hard hat deploy /types. All right, so stop complaining about everything, hasn't it? Except for this, because I've misspelled deploy governance token. Let me just do that. There we go. Okay. Now, this stuff is a bit of hard hat magic, right? What's happening is hard hat is injecting this really powerful object called the hard hat runtime environment, which has everything we need. Okay, it's injecting that into our scripts automatically in the background, but it can only do that if we go back to our hard hat config.js. This is the hard hat config file that comes out of the box, right? We need to import a few things in here to make sure that this object from the hard hat config file includes the HRE and injects all the stuff we need into our script. Okay, so here we do import at type chain /hard hat. That's one of the imports we need. We also need to actually import the hard hat deploy package that we did the yarn add about. And finally, we need to import the Nomic Labs one, and we want to make sure that it is the hard hat ethers one. Okay. Now that we've done all these, that gets imported into the global scope in this file. That then becomes available, including when it injects into our function that we've declared here, the hard hat runtime environment. Okay, I'm going to unpin that. Thank you, Victor. Thanks for acknowledging that. Appreciate it. Cool. Okay, so you'll see something cool here. Let's go to the terminal. And if I just do yarn hard hat, okay, what happens is now that we've initialized the project, if we do yarn hard hat, we don't initialize the project anymore because it's already done. We instead get a list of all the tasks and commands we can use for hard hat, right? And you'll see, oh, here we go. You know what's happened? It's because we haven't changed hard hat to a TypeScript file. Love it. Okay, now hopefully that'll work. What do you think? What do you think? More errors? No, it worked. Cool. So what happened there, for those who missed it, I hadn't changed my hardhat.config.js file to a .ts file. And so when I ran the command, it basically said you can't do an import statement in what it thought was a Node.js environment, yeah, common JS. Anyway, so now that I've done this, sorry, I just had a timer go off on my watch for some peculiar reason. Now that I've done yarn hard hat, you'll see that it has a command here called deploy, which deploys all the contracts. The real magic here is you can see that now because we've imported this stuff into yarn into the hard hat config file. So if I comment that out, you will see that this deploy thing will not happen the next time I run yarn hard hat. It will not give me the deploy task. Okay, so that's what we're doing here is we're injecting all this stuff here, and the hard hat deploy package gives us this magical ability to get this new command called deploy that will deploy all our contracts. Okay, so that's why we use the hard hat deploy package. You don't need it. You can use hard hat without it, but it's a lot faster from a dev tooling point of view. Okay, now we've got our first script. Well, it's not complete. It's far from complete, but let's see if it even compiles and works. Right. So how we do this is we do yarn hard hat deploy. Remember, that's what we were just talking about. You can ignore all that tag stuff. Just do yarn hard hat deploy. I've got this autocomplete thing, so ignore all the faded stuff. Yarn hard hat deploy should now deploy the script that we've just done, the deploy governance token, or it should run that script. It doesn't deploy any contract because we've not referenced any contract in there. And we should see the console log statement just to make sure that everything is running fine, that the TypeScript is compiling okay. So let's make sure we're doing that before we proceed. Awesome. So we can see woohoo that. Wow. Okay. So we know that our hard hat deploy, if you see that, that means your hard hat deploy is wired properly. It's reading in the correct things from hard hat config, etc. Okay. Or most of the correct things. We'll find out some more stuff in a bit. Excuse me. Actually, I'm just going to I'm going to finish off my tea. It's really cold now. So because we were in the Southern Hemisphere here in Australia, it's getting into winter. I'm not happy about that. Obviously, it's not as cold as some of the really cold places in the world. But, who likes, I don't like winter that much, so it's getting kind of cold. Anyway, so we've done our deploy token. We've started a deploy governance token, right? So that's what we started. So now we need to write some real code to get this thing singing, okay? So the first thing we need to do, though, is we need to update our config file to refer to a bunch of the networks we're going to use. Remember how I said that hard hat has its own inbuilt blockchain network, right? So we need to configure that so that hard hat, when we do hard hat deploy, it knows which network to deploy to. So let's start here in your module.exports. We're going to change this and we're going to make this a config object, okay? Because we're now using TypeScript, right? So we're going to say const config. This is of a type hard hat user config. And if I press enter, it comes in from, actually, that's not the package it needs to come from. It needs to come from the package config package. So make sure you import hard hat user config from hard hat /config. That's the type that we've got here, okay? And then what we want to put here is right here underneath this, we're going to talk about networks. Okay, we're going to say the default network is going to be something called hard hat. This is the in process in the hard hat execution. Okay, we're going to now configure a bunch of networks, and the first one is going to be hard hat. This is also an object. We're going to give it a chain ID of 31337. Now that's hard hat's default chain ID. Okay, so if you want to look that up, go to Google, type in hard hat default chain ID, and you'll see that that's what they recommend is their default value for the chain ID. Okay, we're also going to create another we're going to create another network called localhost. And this is going to have the same chain ID. So I'm just going to copy this. All right. So we have these two networks. So this basically tells Hard Hat which networks we want to use. Okay. Now we're also going to need another property in this config called named accounts. Basically, as you know, every Ethereum user, if you like, is an account. There's an external accounts, and then there are contract accounts. We're going to have to name some of the accounts that we want to use by default in development. So we're going to call our first user. We're just going to call that the deployer because that's us. We're deploying the contract. So the deployer is going to have a default value of 0. 0 is an index. Okay, that's the index. For Hard Hat gives you about 20 different accounts, right, to use, wallet accounts to use, if you like. And so we want the 0th account. So the 0 to 19, we want the 0th account. That's going to be a deployer account. And we'll see more about this later on, okay? So that's our named accounts. Now we want to remember to do export default. What have we called it? We've called it config, imaginatively enough. So we're going to do export default config, okay? Now going back to this, you know something really weird? My Google Home suddenly started playing music. There's no one at home except for me. So that's really weird. Hey, Google, can you stop the music on all speakers? How weird. Like I can hear, I don't know if you guys can hear it. Anyway, she hasn't stopped playing it. Anyway, hopefully it's not going to disturb you guys. I can only hear it faintly anyway. Right, okay, so we want to try and deploy this stuff to these networks. But before that, we need to do a bunch of things in our deployed governance token script. Okay. Right, guy. Yeah. Right. More performances of yeah. I wish that were true, man. I wish that were true. If you guys are wondering which comment that was no, not that one. Sorry, that one. Yeah, I wish it were true. Not sure if it's true of me. Anyway, thanks for the joke. I love it. So for this deployed governance token script, we need to start accessing a bunch of things, okay? We need to first do, you know what, let's get rid of that woohoo, it's distracting me a bit. So we need to get the named accounts. Remember, we just set our named accounts as the deployer and 0. We need to get that. We need to get the deployments object and the network. Now you can follow all this stuff. You can look at the documentation for Hard Hat to see what's going on here because all this is beautifully documented in Hard Hat. But we get these 3 properties, if you like. That should be get named accounts. There you go. And I think I deleted deployments, didn't I? Yeah. So we want to pull this off the HRE object that we got here, right? That's going to be passed in automatically by the framework that we're using. We want to pull these values off that. And then what we want to do is we want to get the deployer object from get named accounts. Now, deployer, you just refresh your memory, is this. We have the named accounts, and we've named one of the accounts deployer, which is the 0th index, right? And we're basically getting that one. And of course, I need to call the function for that to stop complaining. And then we want to get a deploy function, which is really the heart of what we're going to be doing in the script. It's a function and a logger. And we want to get that off the deployments object. Okay, so we got deployments up here. And from that, we're pulling off these 2. And we've got a deployer here as well. Now, all of these things are from the Hard Hat runtime environment, which got injected from here. We covered that a little while ago, so I'm not going to mention that one again, okay? Now, let's start actually deploying the governance token, right? So let's say log deploying governance token. And let's just, actually, let's do that later. Fine. Yikes. What are we doing? What are we doing, Zibin? Okay, cool. And then what we want to do is we want to actually deploy. So let me show you how that works, right? We're going to say we want to deploy actually an async function. So we're going to have to deploy. What are we going to deploy? We're going to deploy our governance token. Now, why am I saying governance token? Because that's the actual name, and we need to get this right, of our governance token.sol. That's actually the name of the smart contract, of the contract, right? So make sure you put this governance, whatever this name is, you put that in to the deploy function. Okay, it has to be the same one. And then we pass in a configuration object, which tells it a bunch of things. It tells us who's actually deploying this. Well, that's the deployer. It says, do you have any arguments to pass through? It's going to be an array of arguments. We'll get to that in a moment. I'll show you how to reason about that. And do you want to print out logs? Yes, we do. Okay. Now, in a real world environment, there is something else that you'd want to add here called, I think it's called wait for confirmations, right? And then you put in like 3 blocks. Okay. We don't need to do that here because we're doing it on our local development network. But basically, that says when you deploy this, wait for confirmations from 3 blocks or 5 blocks or 1 block, whatever it is, before you take this contract as having been authoritatively deployed. Okay. So we call that, we assign this to const governance token is equal to that. Okay, so we get a reference to the deployment object from Hardhat, and then we say log deployed, put in quotes so we know what we're saying here, governance token, and we want the address at, we've got the object name here, so we'll use that governance token dot address. Okay, you know what? Let's give this a 0, 1 so we can track in our console which script this is. Okay. Now we want to do that, and right at the end here, this is really something about the Hardhat deploy package. You'll find that if you're using that repo that I've linked to, you'll need this to run some of the tests in that. Okay, but here you go. You just want to copy this in there, and this basically tells. It's just some configuration stuff for the Hardhat deploy library. Okay, we'll have to put this at the bottom of all the deployment scripts, but make sure you export this this function, because this is your deployment script to deploy the governance token. Okay, very, very important that you export it. Now, you know what time it is? It's time to try and run yarn hardhat deploy and see if it works. So what are we expecting to see? We are expecting to see all this information about its deploying stuff and that it successfully deployed the governance token, and it should give us an address. We should also expect to see some of these logs. Hope springs eternal, my friends. Hope springs eternal. Here we go. Oh! Yes! So we've deployed the governance token. Take a look at that, okay? Said it's going to deploy it. It gave us a transaction. That's great. All that stuff is good. And then it said 0, 1 deployed governance token, and that's the contract address. That's in our Hardhat local in-process development blockchain. We get our own little private in-process blockchain that we can play around with. On that blockchain, we now have a contract called governance token deployed with its own address. Sweet! Yes, Rifa. Yes, etc. Yes, awesome. All right. So far, so good. Hey, but we still got so much to do, okay? So, boom, here we go. Now, we're actually not done with the governance token, because the way voting works, especially with the OpenZeppelin contracts, is you can't just have a token and vote. You got to delegate it, and the delegate votes. Now, you can delegate it to yourself, which is how you normally do it, okay? So what we want to do is we want to write a little helper function. We want to write a little helper function called delegate, of course. It's called delegate. What else is going to call it? Because that's what it's doing, right? And this is going to do a bunch of things. It's an async function, importantly. But what it's going to do is it's going to take a governance token, let's call it that, address, which is going to be a string. Thanks, Alex. Believe it or not, this is without any caffeine, man. It makes no difference to me. Caffeine doesn't affect me at all. But, my mom used to say that to me even when I was 4. So, it may not have anything to do with caffeine, but it may have just to do with the fact that I'm a bit strange. Why do I have that? Oh, yeah. There you go. I'm just hyper, naturally hyper. Okay. So I hope you guys turn the headphones on when I'm yelling and screaming, because I get really into my coding. I get really into the DAO stuff. I get really into the blockchain and Chainlink stuff. Like, I'm super excitable when it comes to this. Okay. Cool. So what we said, we're going to delegate to a governance token address. We're going to delegate certain voting rights in the token to a certain account. Okay. So we're going to call that the delegated account. That's also going to be a string. And how are we going to do this? Well, we need to access the governance token and call the delegate function on it. So let's start with accessing the actual governance token. Remember, we're going to call this delegate function here. And we're going to call it here inside the deploy governance token function. Okay, we're going to call delegate here. And at that point in time, by the time we call it, the governance token is already on the blockchain. Okay, so what we're going to do here is we're going to say constant governance token, and we're going to get it from ethers. We'll import that in a moment. We're going to call get contract at, which is going to say get me the contract called governance token, which is at the governance token address. Okay, so now we have the governance token. Let me just bring that up because it's broken. It's wrapped it over a couple of lines, and then we're going to say, well, let's await governance token dot delegate. So this is the action of delegating it. We're going to delegate it to the delegated account, which is going to be us. Okay, but we have to do the step. That's just how the voting works, right? And then the response from this is known as it's basically a transaction. So we're going to call it a transaction response. Now, a transaction is something. It's a call to a smart contract on a blockchain that changes the state of the blockchain, specifically of that contract. When we call delegate, we're going to create a new state in the contract where the delegate's going to be this delegated account. Okay, so we get a transaction response for that, and it's good practice to just await that TX response for one block, or something like that. Okay, TX, wait TX response. Cool. So we await that. Okay. Now, remember how I told you that ERC20 votes, the contract that we're inheriting from for the ERC20 token, has this concept of a checkpoint, right? It's a snapshot in time that summarizes the voting power as at that checkpoint time. Let's find out what the checkpoint is for the governance token for this delegated account. So when we delegate it to them, we want to check what the checkpoint is. It should be 1 at this point in time because we've awaited for 1. We've awaited the TX response for 1. Okay. So what we're going to do is we're going to do console.log. I'm sorry about all that stuff coming up. I need to try and disable that, but there's just a lot of IntelliSense stuff coming up, isn't it? Anyway, so and we're going to say checkpoints. Correctly, we can say it, and we're going to say let's get the governance token. Let's get num checkpoints. That's the name of the function we want to call. And we're going to pass it the delegated account. That's going to console.log for us the checkpoints. Now, the reason we're using console.log and not log is because this is the whole new function, guys, delegate, right? Delegate's outside the scope, so we don't have access to log, so we have to use console.log in case any of you were wondering why we're doing that. Cool. Now, we haven't imported ethers. Well, actually, we have. So my system automatically imported ethers because I called it here. Ethers get contract. Make sure that you've imported that, okay? Import ethers from hardhat. That's the one we want, all right? Now, we've got the delegate function ready. It's an async function. Let's call it await delegate. And then we want to pass it the token address, which we now have as governance token.address. And we want to pass it the account that we're deploying it, that we're delegating to, which is going to be us, the deployer. Remember, we got the deployer here. Us, we're going to delegate it to them, okay? And then we just do a quick log and say, yeah, sweet, delegated. Okay, so now this should actually complete the script for our governance token. This is it. We're done with this governance token script. So let's quickly run and check, and we should see checkpoints is 1. Ooh, every time I do yarn had deploy, I get like slightly nervous, like these butterflies in my stomach. Like, geez, it's just code, guys. Like, obviously it's going to break at some point in time and you got to fix it like now. See, just knew it. It's going to happen. TX response is not a function. Interesting. Did I? Okay, that's because this needs to be .wait. Okay, so in case you guys were coding along with me, I had incorrectly said await TX response brackets 1. It's got to be await TX response dot wait and then 1 in parentheses. Okay, let's do this. Fine. Oh yeah, delegated checkpoints 1. Yes. Awesome. So this means our governance token is now on a little test blockchain on our system. Okay, good. So one script down, just 4 to go, and then we have the interaction script. So guys, we've got to step on it a bit. Okay, so we've got not that much time left, so I'm going to try and rush this as fast as I can, and see how fast we can go with this. Okay, now we're going to do our second script, which is going to be called. Now, what's the second one that we want to? We've done the governance token. The next one we want to try and do, because this order matters. The next one we want to do is the time lock. So we're going to say, let's call this the deploy time lock script. This one I think shouldn't be too complicated or take too much time. What we're going to do is we're going to, let me close that out. I'm going to go back to my 0-1 script, and I'm just going to copy a bunch of this stuff. Okay. Be careful when you're copying. I'm just going to copy this. So what am I copying? I'm copying the stuff that I imported. And I'm copying my function signature. I'm going to rename it, and I'm going to copy the stuff where I'm pulling off the stuff off the hard hat runtime environment, because all of that's pretty much going to be the same. I just had to change the name. So I'm going to paste it there. For the moment, I'm going to close out the function. I'm going to make sure I change, try not copy the whole thing, right? There you go. I need to copy the import statements as well, all the way to the end of deployments. And then I'm just going to paste that into Timelock. Good Lord, what's going on here? Let me just close that out. Okay. Okay, so we're importing, and now we're going to call this the time lock, okay? Because that's what the script is about. And I'm going to make sure I remember to do export default. Just getting the boilerplate stuff done. Export default time lock, and I want to also do the little bit of config here. But should we call it deploy time lock? Yeah, maybe we should call it deploy time lock, so that we're being descriptive. Okay. Yeah. And we want to call it deploy time lock, and we want to say tags is equal to an array, and we do all, and we want to do time lock. This is also string. So now we have the boilerplate stuff done. Deploy time lock. It's just going to say that it doesn't know the word. That's fine. So we have more or less the same sort of setup as the previous one, right? But the difference here is, well, let's say we're going to say, what are we doing here? We're going to say we're deploying the time lock contract, and that's it. Okay, and then we want to do await deploy. What's the time lock control contract called again? It's called time lock. Okay, good. So we want to make sure we get that name right. That's why I'm being super cautious about that. Time lock. Then we want to pass in a configuration object as we did last time, which is going to be the usual. It's going to be from deployer args. Oh, last time I didn't take you through the args, but I didn't need to because we didn't have to pass args to instantiate the governance token. But this time we will need to. And so I'm going to close the string there. So I'm going to tell you why, because we do need to put some stuff here in args, okay? Now, let's go back to our timelock.sol contract that we wrote. And we saw that we were passing in 3 arguments into our constructor there. The minimum delay period, the proposers array, and the executors array. That's what args is all about. What we're saying is, okay, when we deploy the timelock contract onto the blockchain, we need to pass in 3 arguments, okay? So we're going to have to put in 3 arguments here, which is going to be the minimum delay. Let's just call it that for the moment. Yeah. We haven't declared it yet. We're going to call it, and then we're going to, in fact, we're not declaring any of these here, which is going to be proposers is going to be an array. Executors is also going to be an array, okay? What we'll do is we'll open our little hard hat helper config file, not the hard hat config file. These are the hard hat helper config files where we're declaring our constants. And we're going to say export constant minimum delay, right? It's going to be 3,600 seconds. So this is the period of queuing, Okay, this is the Timelock queue. We're also going to say export const executors. It's just going to be an empty array. Okay, and then we're going to say same thing for proposers is going to be. So back in our Timelock, we need to try and import these. So we do import min delay from hardhat helper config, and we also want to get proposers and executors. Okay. Let's understand what's going on here very quickly. Proposers are those that can propose a governance. Okay, we're going to change that in a moment, and we're going to say only the governor control contract can propose. Okay, and that's how we want the automation to work, the entire on-chain automation. Okay, minimum delay is the period of time that we need to wait after a vote has passed, a proposal's ready to be executed, but before it executed, we wait minimum delay. We talked about that so that people who are grumpy can get out. And the executors is an array of addresses that can execute a successful proposal. After the minimum delay is over, you execute, and only the authorized people in the executors array can do it. Now we're going to say anyone can be executors and proposers for the moment. We're going to fix all that in one of the later scripts, but we do want only the governor contract to be the proposer. Anyone can be the executor. That's fine. So now that we've got all this here, we need to do a log at the end of it, saying log 02. So that we know which step we're at, and we can say Timelock contract deployed at Timelock address. And we don't actually have a Timelock yet because I haven't assigned the result of this to the result of calling deploy and needs to be assigned to Timelock, and now Timelock is there. Okay, so we have the address there as well. Now, hopefully, if everything goes well, in case you guys are wondering, I should clarify this. This is just going to be, because we're using TypeScript, this is just going to be an array of strings. Okay, these are just going to be string values. But in any case, for the moment, we're going to be we're just going to pass them in as empty arrays anyway. Okay, so now let's do a quick yarn hard hat deploy, and hopefully it's working. And then we need to keep powering on. We're expecting to see that the Timelock contract has been deployed. Excellent, there it is. Timelock contract deployed. That's the contract address. Very good. Quick. Excellent. Not much time for that stuff anymore. Now we need to keep powering through. Okay, so we've done number 2, done the second deployment script. And I think you can tell now that it's time for the third one. So we go back to deploy folder and we do the third one. And the third one is we want to deploy our governor contract. Okay, this is the one that's going to have all the voting mechanics in it. All right, excellent. Now we do the same drill. Copy and paste the beginning stuff from here. Okay. We may not use all those imports, so we may have to tidy up the imports later on, or we won't. We may not, right? Like, got so much going on at the moment, and we're going to call this deploy governor contract. Do export default that, and we also want to do deploy governor contract dot tags is equal to an array where we give it an old string and we give it a governor tag. All right, it's basic boilerplate all over again. Okay, now if you look at the governor contract that we wrote, governance contract, that's fine too. You will see that we need to pass in the wrong contract. We were looking at the governance token. So you'll see that the governor contract needs to, there's a bunch of stuff, right? This is the one that we got from the wizard. And we're passing in a bunch of information. We're passing in the token address. We're going to pass in the Timelock contract address, which is why that was done in 0-1 script and the 0-2 script. That's why we did in that certain order. And then we need to pass in these constants in the voting delay, the voting period, and the quorum percentage, which we've declared here in the hard hat helper config file, not the hard hat config file. Okay, so we know we need to pass all that stuff in. So what we're going to have to do is we're going to have to we've got the governance token already up. We've got the Timelock contract already up. Let's try and get access to those things. Okay, so there is a very useful function that's available in this deployments object called get, and that's basically hard hat's way of getting you a contract that you've already deployed to the local development network. Getting you the deployment object, which is slightly different from the actual contract. Okay, but we'll start with that. So we can do const governance token. We're going to get access to the governance token first, and we're going to say await get. Remember, the name is important here, governance token. Okay, we're going to do the same thing to get the Timelock, which I'm pretty sure was yeah, T and L uppercase. Okay, that's important stuff. And we're going to call this Timelock. I was guessing that one. Okay, now we saw the inputs that the governor contract requires. It requires all these things: the token contract, the controller, and the three constants, right? So what we're going to do is we're going to do we're going to do the same thing that we did last time, which is we're going to do a const something or the other and deploy, and we're going to pass in the arguments. Okay, so we're going to say governor contract await deploy. It's called the governor contract, and we're going to pass in the object. It's going to come from deployer. We can take all the stuff again from one of the previous scripts. It's from args and log. Okay, from args, we're going to fill that in a moment, and we want to log it. So we're going to say true. Excellent. So why is that complaining about it needs a comma somewhere? Oh, that's why, because I haven't closed the bracket. There we go. Okay, so now the args are the arguments that the constructor to the governor contract takes, right? So we have a bunch of them that we need to do here. First is we're going to pass it it needs the token address, so we'll say governance token.address. Next one is it needs the Timelock address, so we're going to say Timelock.address. Okay, and now we want to make sure the order is correct. So we pass in the token address, the Timelock address. We want to make sure we pass in voting delay, voting period, and quorum percentage. So that should come through from voting delay, voting period, and quorum percentage. All of these, just reformatted it there, all of these are going to be imported from hard hat helper config, right? This file, we declare them right at the start because we knew we were going to use them later on. And now we've got the governor contract. And so hopefully what we should do is we should say log 03 governor contract deployed at governor governor contract.address. Okay. And now let me just double check this because I think we should also have an no, that's fine. We're on track. That's good. I just wondering whether I missed out something there. So we should now be able to run this and have 3 fully deployed contracts on our local blockchain. Okay, so let's give this a shot. Okay, so we have an error. Let's try and fix this one. Cannot find artifact governor contracts. Remember how I said you have to be so careful with the name? Guess who wasn't careful with the name? All right, let's do that again. Oh no, I haven't saved it. Hang on. Make sure you save the file. So for example, I had not saved it, which is why there's this little round dot on the top, right? If you don't save it, you're compiling an old version. So you just want to save it before you actually run yarn hard deploy. Yay, governor contract deployed. Excellent. We've done 3 of the 5 scripts. 3 of the 5 scripts. All right. Let me just check. Didn't know we could reference the contract with his name to fetch it locally instead of copying and pasting addresses. Yeah, well, that's the advantage of using the hard hat framework, right? Using hard hat and ethers, that's how we do it. And yes, you can actually do that from the JavaScript console as well. So you can use the ethers.js library, which hard hat wraps around in order to access contracts by their name and their address, and stuff like that. So you can do that in the local environment and even on the proper environment. Okay. So we've got 3 contracts. Now we need to do the 4th one. And this one's an interesting one because this is the one that's going to set up all the access control and the roles, right? So this is going to be the heart of decentralized governance, if you like, where no individual gets to control these things, but we give the contracts the power to control and the power of governance, which is what a DAO is all about, okay? So 04, because it's the 4th one, and we're going to call this one setup governance contracts.ds. Okay, so it's the setup stage, really. That's what this one is about. And this one's going to be important because we're going to give a couple of permissions. We're going to make sure that the governor contract has the proposer rights. We're going to make sure, we'll talk about it in more detail, but we're going to make sure that the box contract is no longer owned by us, the deployer, but gets transferred over to the actual Timelock controller. And so we're going to fix some things like that. Okay, so we use the same sort of approach to this. Let's just copy and paste all the stuff again like that. And then we put that here. I'm actually just going to take out that for the moment because I don't know if we're going to be using, I can't remember if we're going to be using these constants right now, but they take up a lot of space. This is going to be called setup governance contracts. Keeping the name longer than I normally would, just so that you guys understand what's going on, so it's nice and descriptive for you. Export default. I mean, you can name it whatever you want, really. I know people have some strong views about this, but it doesn't need to be like that, right? Cool. All right. So we have this basic stuff set up. We have a hard hat runtime environment coming through. Now, we need to get access to our governance contract. We need to get access to our governor contract. We need to get access to our governance token, our governor contract, and our time lock, okay? Because we're going to be manipulating stuff in all of these. So let's start with the, yeah, that's helpful. Thank you. Start with the governance token, and we say ethers.get contract. Now, we want to make sure that we import ethers from hard hat, okay? Do not do this one. That won't work because hard hat wraps around the ethers library, so it includes the ethers package in it. So just get the one from hard hat. That's the only way this stuff will work because it adds a whole bunch of functionality to what comes out of the box in ethers. So we want to do get contract, so the governance token, and we want to say who's going to be signing this? Well, it's the deployer. Or who's going to be, who's going to be the one that's calling this? It's going to be us, the deployer. Then we want to do a const time lock. And let me just close that out on the side. Radio const time lock. And this is going to be, again, similar. We're going to say, you just copy and paste the bit on the top. And we're going to call it time lock. Okay. And whoopsie, wrong button there. And then we want to just reproduce that down here, governor. And we're going to call this the governor contract. That's what we have called it. Haven't we? Yes, that's what we called it. Okay. Save the file. Correct the spelling for governor. And so now we have these guys, okay? Now we're going to have to set up a bunch of roles. Now, let me see. Remember how we talked about the governance token having all these, no, not the token, the governor contract. Too fast in this thing sometimes. we want to make sure that we understand all the roles. So there were a bunch of roles, actually. Maybe it was in the Timelock, wasn't it? I think it may have been in the Timelock controller. There we go. So these are all the roles, okay? So we need to get access to them from the Timelock because these are just constants. So that's what we do now. Close out all the stuff. I can close out 03. And what we do here is we say, let's just log it. Setting up governance roles. And say, let's do await time lock. Isn't that what we call it? We call it time capital L, time lock. Actually, it's a constant called proposer role. We just saw that in the actual time lock controller, in the time lock controller Open Zeppelin contract. So I'm just going to replicate that. And what this is going to be the executor role. And we're going to say this is executor role. And then this one's going to be the admin role. And we're going to say time lock admin underscore role. Okay, so what's going on here? We're basically saying get us those three roles, get us the constants, because we're going to use these constants in a moment, okay? Now, what we want to do is we want to give the governor contract the proposer role. We want to give anyone the executor role, okay? So it doesn't have to be locked to anyone, because anyone can say, okay, now it's gone through governance, let's just execute and give effect to this. And we want our deployer to stop being the admin for the box contract, right? We want to revoke that right from us, the deployer, okay? So that we make it truly decentralized. So let's do that. So we're going to do, we're going to change the proposer like this, okay? We're going to say proposer transaction, because this is going to change the state. So it's going to be a transaction that gets returned. And we're going to say time lock. Yep. And we're going to say grant the role of proposer, right, which we got up here in line 17. We're going to grant that role to the governor. Okay. And the governor is this one, because we got access to that here. And we're going to do, okay, great. Let's await that, because when we do a transaction, we want to give it a little bit of time to settle, like that. Now we're just going to copy, I'm just going to replicate these, because we're going to pretty much do the same sort of thing 3 times, okay? This is going to be the, what else did I say we want to do? We want to do the executor change, right? So this is going to be executor transaction is we grant the role of executor role to the to no one, actually. So we're going to say we're going to grant, okay. In Ethereum, when we want to grant it to nobody in particular, which means everybody in particular, we just call it address 0, okay? And I'll show you what that means in a moment. But we're going to declare this constant in a moment. We haven't yet done it. And we want to make sure that we're waiting on the right one. So we wait on execute a transaction, not wait. And then the final one is we want to revoke, we want to actually revoke the role in the last one. We want to revoke the admin role. Yeah, and we want to make sure that the deployer no longer has, so we're revoking it from the deployer. Therefore, this is going to be called a revoke transaction. Let's call it that. And we're going to wait for that in a moment. Address 0 is basically saying it's a 0 address. So what we're going to do is we're just going to simply put in, and I'm going to put this for you in the chat so you guys. Thank you, Rusvolvo. That's very kind of you to say. I appreciate the feedback. I'll share the feedback link with you guys later on. So, please tell us how we can get better and what we did well and what you like. So I've just pasted this in. This is address 0, okay? This is this constant, which we haven't declared. Go back to the hard hat helper config file, not the hard hat config, the helper config file, and just put that in there, okay? This 0 address is basically saying no address in particular. So what that really means when we do this is we're granting the executor role to the 0 address, which means everybody. 0 address is not here, so let's import it. Oh, it's address 0, isn't it? What do I call it? Have I gone and mixed it up? Address 0, address 0, address 0. Yeah, cool. So let's save that. Hopefully you guys have got that. And okay, and I think that's pretty much all we need to do for this one. Oh, we do need to export the tags, don't we? So set up governance. Let's call this one. Okay. Set up governance contracts tags is equal to all, and we do setup. All right. Now, I just make sure that we have some of the things that we've done right. So I don't think we're actually using the governance token here. Anyway, let's just leave that in there, but I don't think we're actually using it. So because I'm looking at this and it's grayed out, so I don't think we're actually using it. But I thought we needed access to them all, but maybe I was wrong. Now that we've set this up, hopefully what we can do is we can do a yarn hard hat deploy, and we should be able to say, let's just say log roles setup. Okay, deployer is no longer the admin for the Timelock contract. Okay. So we should hopefully see that. Let's give this a 0.4 so we know which stage we're in. Whoa, not do that. And yeah, hard hat deploy. You guys know the drill. You guys know what happens. You guys know can't speak anymore. You guys know what happens. Okay, so something broke. Let's figure out what it is. Oh, Timelock to admin role is not a function. That's interesting, isn't it? Because it really, what would it be? Oh, I know what we should do. This is how we diagnose it. Take a look at the Timelock controller. What's it called? Timelock admin role. That's why. And I call it that. Timelock admin role. There you go. So you've got to make sure, because basically what we're doing is we're pulling off properties from the Timelock controller.sol open Zeppelin constants, right? So we want to make sure we call it exactly what is meant to be called there. Okay. Now, let's try that again. And for the tutor, hopefully, yes, role setup. Okay, deployer is no longer the admin. God, I'm happy to see that. Disproportionately happy, you may say. All right, let's we've got one more to go, guys. We've got one more, no, sorry, no, got one more deployment script to go, and then we have the interaction scripts, but we're getting there, okay? We're getting there. Now, the interaction scripts, they also can take a little bit of time, so I'm gonna try and race through this as best we can. So the next one, we've done a bunch of things. We've deployed the governance token, we've deployed the time lock, we've done a whole bunch of setup, we've deployed the actual governor contract. What's left is the fifth script, which is around deploying the actual box contract, right? So hopefully not going to take too long. But let's do our usual stuff. We know we need to start off with all this. So I'm just going to copy that preemptively, because I think I've learned how to do it by now. And then we do 0.5, excuse me, deploy box contract dot, spell contract right, dot ds. Then we're going to call this deploy box. And we close the function up there. Do a usual export default. Oh my gosh, some days, just hard. No good reason, mainly because my fingers are all over the place and not doing what they're meant to be doing. So we do deploy box. Also, we want to add the tags functionality here. It's fine. So we do an all string and we do a box tag. Cool. Now we need to get to the action for this one. So we've got all the stuff that we need. We pulled off all the stuff from the hard hat runtime environment. And we're going to say, let's actually say what we're doing. We're going to deploy, yikes. Okay. And we're going to say, wait, deploy box. Isn't that what we call it? Let me close that out and pull up box. Yes, we call it box. we want to deploy box and send it this object saying from moi, the deployer. The argument, well, we'll take a look at it, but as I remember it, I don't think we had any. And then are we wanting to log? Yes, we do indeed want to log. And that's that. And now we need to assign this to not box. We already done the await. So we've got the box thing. Hopefully that's going to do the deployment. But we've got to transfer the ownership of box to the Timelock controller. Remember how we said that it can't be mine anymore? Because, hey, if I'm the one deploying it from me, we need to transfer ownership, right? So we need to get access to the box contract after we've deployed it and change its ownership, okay? So here's how we do it. We use ethers again from hardhat. Okay, so we've already got that import in there because we copied it from the other file. And we go, we get a reference to the box contract. After it's been deployed, and we say ethers get contract at, just mixing up the functions for change. And then we say, well, we've got the deployment and it's this box contract at this address, okay? We also need the Timelock to be the new owner. So we need the access to the Timelock contract because we're going to give it ownership of the box contract. Yep, I think that's the name of the contract. That's right. Now we want to say, well, let's do box contract. And we want to say transfer ownership. This is, I'll show you in a moment. You want to transfer the ownership to Timelock. And it would help if I spelled Timelock correctly, wouldn't it? Yes, mate, it would, Zubin. It really would. We want to give this a transaction. Oh, it is a transaction, right? So we're going to say constant transfer transactions. That's awaited. Remember how we await everything? We await all the transactions. Transfer transaction. Let's wait for one block, okay? And then we're going to triumphantly declare, I hereby declare that the ownership of the box contract, how's my lousy British accent, guys, of box contract is transferred to Timelock. And, oh, no, that's not what I wanted. That's what I wanted. And this needs to go in there. So we're saying, and transfer needs to be spelled correctly because what's the point of speaking with a posh British accent if I can't spell the word transferred? Right, so ownership of the box contract is going to be transferred to Timelock. Now, I wanted to show you where we got transfer ownership from. So let's go to box.sol. We've inherited it from Ownable. Remember, we took Ownable from OpenZeppelin because we needed to transfer ownership. We needed to make sure that the Timelock owns box. And if you look for the symbol here, transfer ownership, there you go. It transfers ownership of the contract to a new account, the new owner. Okay, so what have we done? We've said we're going to transfer ownership of the box contract to the Timelock contract. That's why it is always an ownable. Okay, so this is script number 5. I'm going to save everything, and I'm going to go, you guessed it, yarn hardhat deploy. And this time I'm really going to drink some water while we wait. Okay. Yeah, figures. Just when I'm in a hurry too. All right. I made the same mistake as last time, guys. I didn't do the wait. Okay. Think I'm lucky? What do you think? Yes, ownership of box contract transferred. 5 scripts, 5 deployment scripts. Boom. All right. 5 deployment scripts. Now we got to do the interaction script so we can actually see what proposing looks like, what voting looks like, and what queuing and executing looks like. Okay, let's get a move on because we've got a lot to try and figure out in the next bit. So now what we're going to do is we're going to create 3 scripts that goes through the process, the life cycle of proposing, of voting, and then queuing it in the Timelock and executing it. Okay, so we're going to create a new folder called scripts. Let's close these 2 out for the moment. We'll keep hardhat helper configure. That's fine. well, I've closed it now. So apparently we're not keeping that open. In the root of the project, new folder, scripts. Okay, and then we start with the propose dot in the scripts folder, propose.ts script. Okay, now, so what this script is going to do is it's going to basically make a proposal. Okay, now let's quickly refresh what stuff is taken into account when we're making a proposal. So, actually, you remember our governor contract from the wizard, right? That had a propose function. Now, of course, it called the super class, but we know what arguments we need. Okay, the propose function needs these ones. Needs an array of addresses called the target. So I'm going to go through each of these. Okay, targets is the contract. In our case, it's the box contract. But because the proposal could affect more than one contract, it takes an array of addresses of target contracts that are subject to governance. That's what target is. It's the array of contracts that is subject to governance. 2, values. It's basically the ether that you send. We're not going to send any, okay, for each of these contracts in order to make them do their thing. You're not sending any value, okay? Call data is the signatures. You'll see this in a moment, so I won't go into too much detail, but it's basically in those target contracts, what function are we calling and what arguments are we passing them? And the description is just a human readable description of what is being proposed, okay? So let's get started, guys. There's quite a bit to cover yet. So we go import ethers, and we go, this is going to be from Hard Hat. You may remember, do not get this one from ethers, get this one from Hard Hat, okay? And then we're going to say, how we're going to do this is we're going to declare a function, pass it all the arguments, these 4 arguments that we need. And we're going to call that function separately, and we're going to throw an error if it doesn't work, okay? So this is what it's going to look like. We've got to export an async function. Yeah, let's just do it this way. Let's use old school function declarations. Call it make proposal. Okay. Oh, get it. And make proposal is going to take following arguments, right? The function to call, and we're going to pass this in the form of a string, the name of the function. It's going to take an args argument, which is basically an array of numbers for us, okay? This is going to be an array of numbers for us because this is going to be the arguments that we call, the arguments that we send to the function that we're going to call, okay? So the arguments that go in there. And then we're going to have the human readable description. So we're going to just call that description. And this is going to be a string. Okay. Now, we need to get access because the propose, I just showed you how the propose function belongs to the governor contract. So we need access to the governor contract. So we do wait ethers.get contract. Governor contract. Okay. Let's assign this to the governor. And then we also need the box contract because that's the contract that is the target, right? That's this one. So we're going to say const box is equal to await ethers get contract box. Okay. Now, before we do that, though, I actually want to try and do some fairly important stuff, which is I want to make sure that we call this. Oh, you know what? Let's, because we're running out of time. Let me just keep going with this. Okay. So we get this. Now, what we need to do is we need to figure out how to call data is a tricky one. We need to basically encode it. We need to encode the call data into a certain format that the proposed function expects, and it's expecting an array of bytes, which is basically a way of, think of it as a string, right? So it's an array of bytes, and so we need to encode our function in the box contract, the one that we're going to call. So what we're going to do here is we're going to say. We're going to actually write this function out, okay? Let's just call it an encoded function call. Encoded function call is in the box contract. We're going to get access to its ABI's interface, right? And we're going to say encode function data. What we're saying there's a function in the box contract, and we're going to encode that function's data into a certain pattern, okay, into a certain string. That will give us the array of bytes that we need, okay? And what we're encoding here is the function to call, which is the argument we passed in here, right? And the args, which is the array of arguments that get passed into the function to call, okay? So this encoded function call is what we'll end up sending in a moment, okay? Now, what we can do here is we basically can move on to actually calling the governor. So we have access to the governor contract, right? We've already used the reference to box. Now let's use the reference to governor. So we're going to say wait governor dot propose, and propose, you remember, takes all these arguments, right? So we're going to need an array of address. We're only calling the box contract, so we're going to say box dot address. Okay, that's the first one. Values is an array of either. We're not sending any. Technically, it's way, but really, either. And then we're going to say the next argument is a bytes array. This encoded call data you'll see is of the type string. So this encode function data returns a string, which means to do it as an array of bytes, we just literally have to put this in encoded function call. Okay, that's the third argument, which is the call data. And the proposal description is the last one, because this is the human readable description, also what we're passing here. Okay, now this gets assigned. So we can call this the proposed transaction is equal to this. And then we're going to do proposed transaction dot wait. This time I'm remembering the wait. And what we're going to do is we're going to assign the proposed transaction, and we call it the receipt. Okay, so basically we get a proposed receipt from the transaction. We're going to use that in a moment. Okay. Now, what's actually happening here is we're saying the proposal is that we're going to call box. We're going to call the store function in box, and I'll show you how we encode that because we haven't declared the function to call yet. We're going to call the store function, add in a new value, and update the value of the box contract. Right? That's what this entire governance proposal is all about. So we now need to make sure that we set it up in such a way that we actually call those functions. So we need to declare what function to call in args are. Right now they're in the function signature, but we're going to call this function in a moment. Okay, we're going to call this function in a moment. So let's start declaring what they are. Let's go back to the hard hat config, the helper config file, and I'm going to do export const function. Just going to call it. This is the store function. Okay, we're just going to give it the string. And we're going to do export constant function args. So this is the args that we're going to pass to the store function. Well, we're going to update the box contract to the number 100. Right now it's an empty value, which is actually defaulting to 0, but we're going to update it. And then we're going to say the description is proposal number 1. Update box's value to 100. Okay, that's the stuff we need. I'm going to go back to that, and we're going to get access to those values in a moment. We can get rid of this for the moment, or maybe I'll leave it there in case you guys want to look at it, because those are the arguments that get passed to governor.propose. Now we need to call make proposal. Okay, so we do call make proposal, and we do a bunch of things, but because it's a asynchronous function, let's start handling the various situations that could happen. If it succeeds, we wanted to just do process.exit with 0, which means it's successful. And if it's unsuccessful, we want to do a catch. We get an error object in a catch statement. And so we want to just do console.log the error. And we want to do process.exit with a non-zero exit, which means something went wrong. Now we don't actually have these arguments. So function to call, we just declared it here, right? So let's import that. So import that. In fact, if I type it in here, it should just come through. There it is. Okay, so we're importing it from hard hat helper config. I think I'm getting a bit hoarse now. And the args is going to be func args. Proposal description is going to be the big capital description that we made over there. Okay. Now it's throwing an error, the joy of TypeScript. It's giving us a red squiggly line because it's saying, hey, function args is not the right type, right? Argument of type number not assignable. And that's because function args we said was going to be an array of numbers. We've just passed it the number. So we just wrap that in square brackets and we get an array. The complaint stops. The joy of TypeScript. Love it. Okay. Now, there's one important piece here. You remember that when we vote, there was a voting delay, right? So what we're saying here is we're going to propose this, and there's a voting delay of 1 block or something, right? Which we were going to wait. What is the voting delay? 1 block. So voting cannot start until a block is mined. And this is the fun part about using a hard hat test environment, is that we can actually start jumping time. So again, speaking of jumping time, I'm sort of running out of time. So I'm just going to start copying and pasting some stuff here. Okay. What we're going to do is we're going to declare in our hard hat, we're going to actually create a new file called helpers. Okay. Right in the root here. Let's create a new file called helpers.ts. Okay. And in helpers, we're going to do a export const move block. So we're going to jump time programmatically. It's very cool stuff. Okay. This is going to be an async function. I'm going to take an amount of blocks that we want to jump by, and it's going to do the following logic. Okay. It's going to say for simple for loop is less than amount. We want to do I++. And then for that, what we want to try and do is we want to say await network.provider.request. And I'll show you what all this is doing in a moment. Basically telling the Ethereum network, please can you call this method called EVM mine. And we don't need to say any commands. This is all part of the EVM sort of standard specification. And then we're going to say at the end of this, console.log moved amount blocks. Okay. So, and you'll see that it's imported network from hard hat, which is what we wanted. So what we're saying is tell the network provider, which is going to be our hard hat instance, to please mine a block for each. So we take the number of blocks that we want to mine, and then we iterated it. So we had 3 blocks that we wanted to mine. We'd say I is equal to 0, 1, 2. For each of those, you mine 1. So you're literally mining a block for each number until we get to the amount that we want to mine. Okay, we're only going to be mining 1. Now we exported this here. So what we're going to do is we're going to call this. We're going to call this here. Time. Close that out. And then we're going to say await move blocks. There's still something we got to do here, though. Okay, it's quite important. And we're going to say we're going to jump by the voting delay, which is just the 1, right? But we want to jump by 1 more, just for safety's sake. So we want to jump 2 blocks instead of 1. Okay. Now the only thing is we want to make sure we do this only in our development environment. Okay. So going back to the helper config file, let's do this. Okay. We're going to say export constant development chains. Okay? And we're going to list the chains that are development only, because we only want to jump time in that. And you remember in our hard hat config file, we added 2 networks. Right? We added the hard hat network and we added the local host network. So what are we saying here? We're saying development chains are these 2 chains. As long as we're on one of these 2, we can do this jumping time stuff, but we haven't actually added the logic to that yet, right? So what we do here is we say if the development chain, and we can import it from that file. So you'll see it's imported here. Now, if development chains, which is an array, if that includes, if it includes network.name, then do this. Okay. Network's not here yet. Network needs to be imported. You'll remember that it came from, I think it came from hard hat, didn't it? So Excuse me. So what are we saying? If we're on one of our development networks locally, we're going to jump time by 1 block. Okay, that's pretty cool. I think that's really cool. And so we do that. And I think, let me just check my notes here. Yep, I think we did the jumping bit. And now we need to, okay, so we've got the proposal receipt, right? Okay. Now what we need to do is we need to access the proposal ID. Okay. So we do constant proposal ID is equal to, we use the proposal receipt, and it's got an events object on it, which will have the proposal ID once the proposal sent to the is invoked on the governor contract, and that's going to have a proposal ID on it. Okay, because it gets returned by that command. And then we want to say console.log, proposal ID is proposal. Okay. This will actually come out as something that's not a string, so we want to call toString on it as well. Right, now I'm going to just copy and paste a bit of code here, because what we want to do is this proposal ID, we're going to use it in subsequent scripts. So we want to be able to import, we want to use the file system, so your local file system, to save it as a JSON file. Okay, so FS, that's file system, let's import that. Import as FS from FS. Okay, that's the file system package. We're going to say save a file. We're going to call it proposal file, and we're going to say JSON stringify. We're going to save the proposal ID, and we're going to save it to this file. Okay, so let me just add this stuff here. Export const. What do we call it? We called it the proposal file. Proposal file is equal to proposals.json. Proposals.json. So now it's going to save to a file by that name. It's going to write to a file of that name. And we can actually just create a proposals.json file in the project root. You can do it here. Proposals.json. And this is going to be a simple JSON file that's going to look something like this. Remember, our chain ID is 31337, and we're going to give it an array. Okay. So what's actually happening here, guys, because I know I'm moving a bit fast, is we need to import proposals file from here. Okay. What we're actually doing here is we're saying, take the proposal file that we got, and we're going to write to it. We're going to save to the network ID. This is going to be that same 31337, and we're going to save the proposal ID to that. Okay, so our proposals.json file looks like that. It's going to insert something to that array. It's going to basically overwrite that, and that's going to be the proposal ID. Okay, because we're going to need to use that. Now, a couple of important things here. We're going to need 2 windows. Okay, so the one on the left is going to be running our standalone RPC blockchain network. It's no longer the in-process one that we're going to use. We're going to connect to the local host. And the one on the right is where we're going to run all the scripts. So on the left one, yarn hard hat node. Okay, this will automatically spin up our local server. And you'll see it gave me 20 accounts there. And what this also does is it deploys a bunch of the contracts. So you'll see it actually did about all our scripts. Right, checkpoints 01, 02, 04, deploying box, ownership of box. It does all that for us, which is great. Now on the right side, we want to do this script that we just wrote. So we want to do yarn hard hat on scripts propose.ts. Because it's breaking, let me just drag this a little bit. Yeah, propose.ts. And this time we want to add the network flag. Okay, so we want to do network local host. Okay. Oh, sorry, yarn hard hat. Hard hat. Okay. What we're expecting to see here is that we should say Oops, it failed. And it's failed at line 41. Interesting. So it's not able to read something there. Was it able to console log? So it did move the 2 blocks, and it wasn't able to read the events. Interesting. Not sure what's going on there. Must have missed something, obviously. So let's see what we can do. I'm going to just close this out. Yeah, interesting. I'm not able to spot. I don't know if any of you guys can spot what's going on here, but So we've passed in all the proposal description stuff. We're waiting for the proposed receipt. We're skipping time. Proposed receipt. Yep, that's definitely what we've got there. So there's something that's going on. Let's see if we're getting an error here. So you can see that it called the proposed function. Yeah, I've got the logs up here again, Rutger. You can see it mined 2 blocks as well. It's called governor contract proposed, so that's fine. That's the transaction hash. That's fine from 2. But it said there's a problem reading the array. So obviously, it's reading 0 of undefined, which means for some reason, events is coming back as undefined. Which is very odd. I'm going to do is let me just keep moving forward with the other stuff, right? So that you guys can see all the other scripts that we need to do, and we'll try and see if because I don't want to run out of time and leave you guys without seeing the other scripts. There's some minor bug here that we'll catch in a moment. So let's go on to the other scripts for a moment, and then we'll come back and see if we can fix that. So we've done the propose. Now we need to do the vote script. Okay. So the vote script is in here. And it's really quite similar when you think about it. It's going to be, pretty much the same sort of approach where we say async function vote. We'll pass in some arguments to this one as well in a moment. Let me close that out for you. And so for this one, we're going to need a proposal ID. So this won't work until we fix the bug in the previous one. But really what we're going to do is we're going to identify the proposal by the ID and then vote on it, okay? So we can say console.log just to let us know where we are. Voting. And then we want to do, let's write the scaffolding out for this, right? So we're going to do vote, some sort of proposal ID. And then we're going to do then is success. We're going to just do process.exit. It's going to be 0 code, and then if it's catch, error. the same thing that we did the previous time. We're just gonna sort of trip it up if there is an issue here, and we're going to do process.exit non-zero exit code. Okay, we'll figure out the proposal ID and stuff and all that in a moment. Really, what we need to do to get the proposal ID is we need to read that JSON file, right? As of now, because it failed, well, let's see, actually proposals.json had a value. No, so it failed, so we never end up getting a value in here. But had the previous script succeeded, we'd get a value in there. And so what we want to do is we want to read that script, right? So we want to go json.parse file system. We need to import that again, and it'll be, I think, read file synchronously proposal file, which will now import. And because we're reading a string, we need the UTF encoding, right? It's actually without a hyphen. UTF-8. Assign this to the proposal. So these are all the proposals we've got, and then proposal ID is, if you remember the proposals file, it's going to have this network ID on it, right? So to get that, we need to say from the proposals object that we've just read, give us the network config chain ID. All right, an exclamation mark is supposed to be there. So what are we saying here? We're saying read that proposals file. That's going to give me an object. From that object, get me the chain IDs array, and the first index in that array is going to be a proposal ID. But we do need to import fs, right? That'll make that error go away. There you go. And close that bracket there. Okay. So and we've imported network from hardhat. That's good. Now, now that we have the proposal ID, the couple of things that we need to know when we're voting in, there are three types of vote, right? There's the yes, there's the no, and there's the abstinence vote, okay? So let's just give ourselves some constants here. So we're going to say vote no, which is actually the 0 one, is 0. And we're going to do const vote yes is equal to 1, and const vote abstinence abstain is equal to 2. All right. And you can make sure you put this proposal stuff outside, because we're going to pass the proposal ID here. We don't really need to put this inside the actual vote function. Okay. So the vote function now, we need to actually vote on the governor contract. So we're going to say ethers.get contract, governor contract, and we're going to assign this to governor. And then we're going to say, right, we're going to vote on the governor. Cast vote is the function we want with reason. So we're going to give it a reason as well. And say, sorry, just looking at some of the comments. It may be the emit. I'll need to look into that. Tarbis, I'll need to look into that. I don't think there's an event emit there, because I think that's already part of the contract we inherited from. But it may be an issue to look at in a moment. Okay, so where were we? We want to do the cast vote with reason. So if you go to the governor contract, right? There is a. Is it in here? Cast vote with reason. There you go. Cast vote with reason, right? So that's one of the functions we inherit. So we can use that one. I'll close that one out as well. So we want to say cast vote with reason, and that takes the proposal ID as an argument, and it also takes the actual vote that you cast. So we're going to say let's vote yes, and for a reason we can say because we like the number 100, because that's what we're going to ask it to do. If we get the first script to work, we'll be able to do this, right? We want to get the result of this cast vote with reason, and we oops, sorry about that. X equal to wait, and then we want to do vote tx. I'm really getting hoarse now. I want to wait for actually just one. Don't need to do make sure we have all the right imports. Yep, that looks right. And what we want to do at the end of this is we want to check what state the governor is in. It should be in a still voting state, right? So we're going to say, what's the state of the proposal that we're looking at? And we're going to say console.log proposal state is whatever the proposal state is. And I'm going to say that this is before voting. Actually, let's just say that here, before voting is that, okay? Right. Now, again, keep in mind that there's a voting period. So when we're voting, it's at the start of the voting period, and we set that at 1 week. So we want to jump ahead in time again, okay? So we want to move forward the blocks by the voting period, which is, how many of 1,000 that was for 1 week. So we use the same sort of logic again. We say, if the development chains that we specified in our helper file includes the network name that we're on right now, that is, if it's either hard hat or local host, we want to do, what is it called? I think it's called a move blocks. There it is. Move blocks by the voting period plus 1. Okay, we want to skip forward in time. And then we want to say again, because we move forward in time, we want to actually repeat this proposal state business, okay? So we'll say, we don't need the let there. We'll say that the new proposal state, we get it again, and we say proposal state after voting is that. Okay? Now, we still haven't figured out why propose.ts is working, okay, or isn't working. So we'll fix that in a moment, but I do want to show you the last bit, the queue and execute, because that's the last missing piece here, right? And if we have time, we'll try and get the whole thing to work. And if we don't, my apologies, guys. Somewhere there's a little bug, but the script works, right? Somewhere. It's just that I missed out something or I mistyped something. But we'll try and figure that out. So the next one is in our scripts file, we want to create a queue and execute. Okay. Queue. I hate spelling the word queue. It's really annoying. Yep. And execute.ts. And so this one is where we're going to put the thing in the time lock, which is queuing, and then we're going to execute on it. Okay. So this is where we actually finally managed to change the actual value. Okay. So home stretch, guys, but we still have to get propose.ts to work, which I know it's not working at the moment, but we'll try and get that to work. But let's try and focus on queue and execute so that you guys get a good sense of how we actually write the script. So now what we want to do here is pretty similar system where we do it. We write the function here. Queue, I really hate spelling that word, and execute. And this function. And again, we're going to do the same thing that we did here, right? So let me just copy and paste that. Pull that out of the side. I'm going to say queue and execute. We don't really have an argument for it right now. So it's going to be that same boilerplate stuff that we did, where we run it and we exit with codes as appropriate. Now, the governor contract is what gives us the queuing ability, right? And you'll see if you go to governor contract, see that the queue the execute stuff, for example, the execute arguments are pretty much the same that we called for propose. Okay, very similar, slight differences, but we'll get to that in a moment. So for this one, let's try and rush through this a bit. We want to make sure that queue and execute receives a couple of arguments because it's very similar to what we did last time. You're just going to say function to call string. We've already declared that in the helper file. We're going to, why is that there? Put it outside the actual argument list. Yep, there you go. And then we're going to say the args, again, is going to be an array of numbers. And then we're going to say, remember that old proposal description thing? Description, also a string. All right, and now we're going to start getting access to various contracts. So we want to get access to the box contract because that's what the proposals and the voting is all about. So we go and we assign it. We're going to need its address in a moment. And remember, we did that encode function, so we can actually try and pretty much do the same thing from there. It's very similar, so we can just use that one. Okay, that's the arguments that get called for the box store function. And then let's give this the arguments it needs. So it needs the function to call, which we remember we had declared it as a constant, and then that function arguments, and the proposal description was the capital all caps description. This needs to import func as well. There we go. And we need to wrap that as an array so that it's because it's expecting an array of numbers. Right. So that's this bit. Now, there's an interesting twist to this. So the governor contract we saw, the actual execute function doesn't take a description as a string. It takes it as a hash. Right. So what that means is we need to actually convert the description string into a hash, and we use a Kachak 256 for that. Okay. So what that looks like is this. We go the description hash is equal to ethers.utils. This is an ethers utility function, Kachak 256, and then pass it ethers.utils, convert the string bytes, and we pass it the actual proposal description. So this is how we need to do it for the EVM chain, right? We convert our proposal description string to bytes, and then that gets hashed, and that's the description hash that gets passed in to the execute function as a description hash argument. So now we have a description hash. Now that we do that, we need to basically queue the proposal right into the time lock. So what we do for that is we go await ethers.get contract, hold of the governor contract, and we do, well, constant governor. Why not? Because that's what it is. Let me just check. Come in here. Cool. And then we do, well, we need to enqueue. So we actually need to enqueue this, right? So we do await governor dot queue, and we know that the queue takes queue. In here, let's see. It's somewhere. We know that it takes a bunch of functions. We know that it takes pretty much the same sort of things as our as the propose. There it is. You went somewhere around. Oh no, that's right. It'll be in controller. So the queue. Oh yeah. So it's one of these governance contracts, right? And we know that it's going to take pretty much the same thing that propose did. So we're going to do box.address because that's the target contract. Okay. We're also going to give it the any ether that it needs, which it doesn't. We're not going to send that at the moment. We're going to give it the function call, which we've got here, encoded function call, which we've encoded, and we're going to give it the description hash, not the actual description string this time. So we'll give it the description hash, and that should queue it. And then so we want to call this the queue transaction, and we want to wait for that. Wait for 1. Okay. Cool. Now, while it's in queue for 3,600 seconds, which was the minimum delay period we set out, if you remember in the hard hat helper config, we said the minimum delay is 3,600 seconds, right? So we need to jump time again. How do we do that? We've done that before, but the only difference here is we need to do 2 things. We need to jump in terms of blocks, and we need to jump in terms of time. So what we're going to do is we're going to do that same development chain stuff. If the development chain includes network.name, then we want to jump time. We want to do move blocks. Yep, there it is. We want to just move forward by 1 block. But before we do that, we want to also move time by 3,601 seconds, right? So what that means is we're going to have to now create a time jumping function, right? So let's do that in the same place where we did it last time, which is in helpers. I'm going to go export const move time. Very similar function, except that we're moving in seconds and not blocks. Okay, so we're going to go await. Again, it's going to be network.provider. This time it's going to be a send. It's a slightly different call. And the signature is also slightly different. So it's going to be increase time, and we pass in the amount in an array. Okay. And then what we can do is we can say console.log moved that much, seconds. Okay. So we need to pass in the amount to this function, but we have access to move time now. So let's call that here, await move time. And this one is going to be the minimum delay plus 1 second. Minimum delay with 3,600 seconds, we're going to add 1. And we need to import network from Hardhat. All right. So that does most of our stuff that we need to do. Now we've only enqueued it, guys, so far, right? We've only put it in the queue, and then we move time. Now we need to actually execute the proposal after it finishes the time lock, right? So we're going to do the governor.execute. And we saw that this one takes pretty much the same stuff as this, as the queue. Okay, it's pretty much the same thing. In fact, it's identical. So where is it? There it is. Governor.execute. We do that. We get the execute transaction. So we say const execute transaction is equal to await governor.execute and with the description hash. Okay. And then we do execute transaction. We need to wait a block. Transaction.wait 1. So what are we doing here? We're just saying we finally skipped time, so we've been able to jump forward 3,600 seconds. We're done with the entire time lock period with the queue, and now we're actually going to, this is the heart of the governance, automatically enforce governance, automatically call box and execute and add the value 100 to it. That's what executing is all about, okay? So we're going to say execute it over here. This string. Okay, and so we should also just announce what we're doing in other places. So we can say console log executed, and we can say after the queue, we can say proposal in queue or something like that, right? So we know what's going on. Now, that's pretty much what we try to do with this entire process. Now, what we want to check at the end of the script is whether or not a box contract actually did have its value set to 100. So we want to do box value is, and we want to do await. Remember, we got the box reference at the start of this. So we're going to do box, and it has a retrieve function that we declared right at the start, right? So box is here, got access to box, and we're just saying now check the retrieve function. And if this works, it should show up as 100. The only challenge, of course, is that we haven't quite, and I've kind of run out of time because I know Harry's jumping in shortly with his incredible presentation. It's going to be a lot of fun. Or maybe, I think maybe Patrick is jumping in for him. But if we can't get proposed to work, right, then I can't really show you the whole thing, but you can just get the stuff off the repo. I've given you the repo link, and I'll send it to you again. And I'll also send you another more full link. It's Patrick's link that has a whole bunch of stuff, including testing and a whole bunch of other stuff as well. So I'm going to put that in here, and you can check the code against that as well. And you can also check against the repo that I gave you right at the beginning, and you can figure out why propose and vote, or why propose wasn't working for me. But we'll give it another crack and see if we can find out why it's not working. But in theory, what we need to do is we need to shut down everything. So we do a Control-C to shut down that RPC node we produced, and we can do that again, yarn hard hat node. Let's fire that up again and try and run the script again and see if it works. So yarn hard hat node will compile everything, deploy everything, update all the stuff around the ownership. All the stuff that we did in the deploy scripts gets done when we do yarn hard hat node. And now we connect to that node, or we run the scripts against it by saying yarn hard hat. There we go. We can say run scripts. I'm not expecting propose to actually work because it didn't work the last time, but maybe we'll be able to figure out what happened. Thank you, Rutger. That's very kind of you. You know how fun it is to live code, and it's hit and miss, right? Most of the time it works. Sometimes small errors come up, and we're sort of running out of time because you can see there's a lot that we've covered. There's a lot of fundamentals that we've gone through, and explaining how we inherit all the various things from the Open Zeppelin contracts and so on. So we're still not able to get it. It's type cannot read properties of undefined reading 0. So that's still a problem somewhere here when we're trying to read the events. And I'm not quite sure why that is. So it must be something that I've done wrong. But anyway, guys, I think it's probably fair to say that it's kind of time to wrap up. I'm disappointed that I couldn't show you, but the fun thing is you basically call these 3 scripts, right? You call this one that we just called, hard hat run scripts. Then you also call the next one, which is, let me see, it'll be yarn hard hat run scripts vote.ts, and then add the network flag. Don't forget to add the network flag because this is all running on the local host standalone thing. But that's the next script that we run. And then the other one that we want to run is simply queue and execute. Okay, so if you run those 3 in order, and once propose is working, you'll have governance happen automatically. You'll skip time, you'll do the voting, then you'll skip time and you'll queue it in. Then you'll skip time, pass the queuing period, and it'll automatically execute. And you'll see that because we're proposing to put the number 100 into the box, right? We're saying the args is going to be 100. That's really what we're expecting to see. Where's args? Args, here we go. Args is 100. So that's what we were expecting to see come out after queue and execute. Okay. So just looking at some of the comments. Gabriel, not sure what you're doing. So you're saying you're not able to find the governor contract. So for example, in my environment, it's definitely happening, right? Because we can see governance token has been deployed. Timelock contract is done. Governor contract is deployed at such and such address, right? So, oh, you may be right about the proposal. Did I not await it? Oh my good Lord, that would be very funny if it did not await it. You are absolutely right. You're absolutely right. Let me just make sure that I've done that in all the right places, okay? So you are absolutely right. You are an absolute genius, my friend. Who suggested that? So the mistake I made was did not will. Thank you for that. You're absolutely right. I forgot to do the await. And I need to do that here as well. That's good. I think that should now work. And I'd love to show you how that works then. Okay. So for this to work, guys, I need to restart the entire local hard hat node. Let's do that quickly. And then I'm going to sign off because I'm taking way too much time. And we need to get Patrick and others onto their thing. Okay. So we're going to do we're going to run the script called propose. Let's see if it works. Yeah, that's not the one I wanted. Went up too far. So hard hat, run script. Excellent. Okay, good. So we have a proposal ID here, and you'll see our proposals. Jason now has a proposal ID there. So that's going to be read in the voting file. Okay, good. This is good. Now let's change to vote. Vote. Let's see if we managed to vote. Nope, something gone wrong here. So we'll have to. Oh, I see. That's because I didn't put the line 39. I think it's because of this. You could say that it's definitely there. Let's try that again. Nope, same sort of thing again. Right, implicitly has an any type. That's no implicit any, that's tsconfig stuff. That should fix it, I think. Oh, I seem to have a problem with my mining. See how many blocks I'm mining? So there's obviously something wrong with what I'm mining there. So let me fix the helpers. That would have been move block. Gotta love these bugs, hey. Voting period +1. Yeah, I'm not sure why I was mining that many. Mine empty. Look at how many blocks I mine, right? Propose start before voting. And this is where right. So I'm going to give this another 30 seconds or so, and then I really have to jump off. Right, so why am I jumping that many blocks? Is it because I'm doing EVM mine, helpers, EVM mine, move to network provider, send. That's not the one I'm calling there though. Let me just run that again. So why is votes? So what's happening here is, that's right. Yeah, the debug process is also a lot of fun. Okay, so it's saying it's already used. So that's because I need to stop this process here and try that again. The debug process is quite interesting because you do learn a lot from it. There's no doubt about it. It's also very, very frustrating because what happens is when you're very close to the code, you end up not being able to spot errors as well as some of you. Thank God, that you guys are also involved because it's always, I find sort of pair programming fantastic for that. So we have all that. Let's do the propose so that works. And then we'll see what's happening with vote. Propose works, and now we know that vote is going to be a problem. Because if you look on the left side, you'll see it keeps mining all these blocks. right? And that's not what we want. But it manages to say proposal state before voting is. So we know we get to that line in the voting.ps file. Now we get to here, and then it starts jumping like this. So I'm going to stop that, close this out, and we know there's a problem. After it prints this, it's moving blocks. Moving blocks is for that number. That number should be the voting period. The voting period is, right. So you're right. Yeah, absolutely right. We should just put that as 5 blocks. I put 45,000 blocks because that's what I imported. That's wrong. Okay, fun. I think we're going to get there now. Famous last words. What do you guys think? We got the local blockchain up with Jan had run, and now we're going to do propose. Good. And now we're going to do vote. Okay. That's the vote script. Should jump forward by 5 blocks there. Yeah, move 6 blocks. Perfect. And now we want to change this to queue and execute. And it should console.log. What do we expect? It should console.log 100, right? Whoa! I haven't used this in a while. Yes! Yes! We finally got there. So, important stuff. Proposal was in queue. We moved forward 3,601 seconds. That was the voting period. Sorry, that was the queue period, the minimum delay. Then we moved a block forward. We executed our automated governance. Okay, the contract automatically said, all right, Box, we're going to update your value. The governor said we're going to update the value. And it updated the value to 100. Guys, that's it. That's what governance is all about. And I'm glad we finally got there. So thank you so much. Thank you so much for your help in helping me, get to that end result. So many of you participated in this. I really, really appreciate you helping me. I love debugging with other people. I learn a lot, and hopefully you learn a lot. If you get a moment, please scan that QR code or go to that link for feedback. Leave me feedback. Tell me what I can do better. Tell me what you loved about it. And you've got some amazing stuff coming up. So I know the next one's going to be the full stack DeFi application. Another code long, 3 hours. Hopefully no bugs in that one, because sometimes you just get unlucky with the bugs. And then tomorrow we have a bunch of really great stuff around smart contract security, auditing, building a Web3 game, another code long. So for those of you guys who are liking this, code long business, get in there, help us understand what you need, how we can help and serve you better. Remember, more than 80% of people participating in this hackathon, the 2022 Chainlink hackathon that we're doing that now, more than 80% of people have little or no exposure to code. Okay, so we want everyone to get involved. Yeah, it looks a bit hard at first, but you can do it. We're here to help you do it. Okay, thank you so much for your time, and I will see you next time.